Hi everyone. Welcome to the session in which we will discuss the detailed solution to GDMT-1. So GDMT was the All India Gate DA mock test that we conducted on Sunday, and lots of students wrote the exam. Whoever has written the exam, congratulations to you. You have taken one step further towards your goal, which is like cracking Gate DA and going into the great college. Now, why is GDMT important? I think everyone knows. It helps you analyze what subjects you are lacking in, and we have already released the results, which means the students who have appeared for the exam, they can go on the portal and check their results, their rank and their percentile. If your rank is low and if your score is low, don't worry about it right now. We still have 40 days left. Okay, 45 days left for the exam, and we can prepare well. Like Gate DA is the last exam of Gate that is going to happen. So it's 15th Feb on 2:30 p.m. So we still have a lot of time. Okay, it's 45 days, and entire December, entire January and till mid-February, you have 45 days. You can prepare well for the exam still. The idea is if you have watched the lectures, then it's okay. You can focus completely on revision now, which means multi-subject tests and full syllabus tests. Even if you have not finished the syllabus completely, prioritize firstly finishing the videos and then solving as many tests as possible. And the ML Hub will conduct 3 GDMTs, which are 3 All India tests, which are free for everyone. It doesn't matter you have enrolled in our course or not. You can attempt it for free, and you can see where you are standing, and all the questions will be like truly authentic. They will be up to Gate level. So we are conducting this test in 3 levels, right? So the first one that we conducted was basic level, which is already done, GDMT-1. Then we will have an advanced level test and a Gate level test. Okay, so this is GDMT-1, GDMT-2 and GDMT-3. So this is already done. And in this lecture, we will discuss all the questions, all the 65 questions which were there in the exam and their detailed solution. So you can ask in the live chat if you are facing any difficulties in the question, any question. If you want me to explain more, you can ask in the live chat. I'll be seeing the chat as well. And yeah, we'll start. Okay, firstly, let me know in the chat if I'm audible and visible correctly so that we'll start the solutions. When will we get the subscription? You mentioned top 50 will get the course. Yes, you will get the course. We will shortly reach out to you on the email address which you provided, email address and the phone. So within a week, we will contact you, and we will ask you for your details, and we will give you the access to the course and the test series. Okay. So we are giving away top 50 students the entire course and the entire test series for free. Okay. And like if you have not registered already, obviously. Okay. Okay, great. So let's start. Okay, we will start with the detailed solutions of each and every subject. So I will take the questions of one particular subject at once, and then we will move to the next subject. The questions which appear to you are in a random order, and that is what will happen in the exam as well. Everyone will get a different sequence of questions. So the questions will be randomized. And now, like, since you are Gate DA students, you can guess how many different possible permutations are there, right? So none of you will get the same order of questions. You will get different order of questions, and that is fine. You can match here, like you can see the questions. We will also release the solutions with the options which you have marked, and what is the correct answer right now. Like during this live, you can go to the portal and see your marked responses and the detailed solution on the portal as well. In the YouTube live, I will solve each and every question, and you can ask me in the chat if you have more doubts. So firstly, let's start with probability and statistics, and here is the analytics of probability statistics in GDMT-1. So probability statistics was of 14 marks. We are trying to keep the subject weightage as close to Gate as possible, but only 2 Gate exams have happened, right? 2024, 2025. It's very hard to predict what will be the weightage of every subject. In Gate CS is slightly easy to predict because there are a lot of papers, okay? But in Gate DA, it can vary a lot. Generally speaking, the weightage of maths is really heavy. Like you can expect half of the paper to be just mathematics. So we will keep almost the same weightage in GDMTs as well, so that you can have the same experience as in exam. Okay, so firstly let's start with probability and statistics questions. Okay, so this was the first question from probability and statistics. It was an MCQ 1 mark question. The joint probability mass function. Okay, always remember, for discrete random variables it is probability mass function. For continuous random variables it is probability distribution function, PDF, PMF. Okay, so for discrete random variable x and y, the PMF, the joint PMF is given. Okay, joint PMF tells us what is the probability of x being 1 and y being 1. Okay, joint PMF gives us that. So this particular probability 1 by 20 is what? It is the probability of variable x being 1 and the variable y being 1. That is given as 1 by 20 and so on. Okay, so joint PMF is given, and if you add all these numbers, they will come out as 1, which means the joint PMF is correct. Now we need to find probability of x being 2 given y being 3, the conditional probability. Okay, so we already know the formula for conditional probability. Probability of x being 2 given y being 3 is, how do we compute the conditional probability? It is the joint probability of x being 2 and y being 3 upon the marginal probability of y being 3. This is called the joint probability. Always remember the terms. These terms are important. Sometimes a tricky question just on these terms can come in exam. So this is called the joint probability. This is called the conditional probability. And this is called the marginal probability. Okay. So how do we compute the marginal probabilities? We just sum that particular column or row. So if you have to find the marginal probability of y being 1, you can just sum up all these three. But we want the marginal probability of y being 3. So marginal probability of y being 3 will be the sum of this entire column, which means 1 by 10 plus 1 by 20 plus 3 by 20, which is 6 by 20. Okay, so this is the marginal probability of y being 3. Now the numerator is the joint probability of x being 2 and y being 3. The joint probability of x being 2 and y being 3 is this value, which is 1 by 20. And hence the overall conditional probability that we want given y is equal to 3 is 1 by 20 upon 6 by 20, which is 1 by 6. Okay, this will cancel. So the answer here will be 1 by 6, option C. Okay, it is an MCQ question, 1 mark question. In MCQ question, always remember there will be negative marking. MCQ means single correct option. So if the question is of single correct option type, there will be negative marking, and negative marking will be 1/3 of the total marks of that question. So if the question is of 1 mark, if you mark an incorrect answer, you will be deducted minus 1 by 3, which is minus 0.33 marks. But in MSQ and NAT question, there will be no negative marking. MSQ is multiple select type and NAT is numerical answer type. Okay, there will be no negative marking. So any doubts in this question? Write in the chat. And then I'll move to the next problem. Question number 1 done. Okay, moving on to the next problem then. So this is question number 2 from probability and statistics. This is again MCQ 2 mark question, which means there will be negative marking. 2/3 of marks will be deducted if you make it wrong. A disease D has prevalence P of D is 1 by 20. Now this prevalence term is not very standard term that we learn in course, but it is given here. So the prevalence or P of D, this might be prior also, right? Prior in naive base is given like this. So a disease D has prevalence P of D as 1 by 20. So the probability of having a disease is given as 1 by 20. Always keep writing down. See, in exam, I'll give you tips for exam as well, how to solve a problem. This will be displayed on screen as it is like this. You are having a scribble pad. On the scribble pad, keep writing all the important information that you get like this. I do this always. Okay, this will help you as well. So probability of disease is given as 1 by 20. A diagnostic test returns positive with probability of positive being if the disease is there is 9 by 10. So conditional probability is given. Now it is given that the diagnostic test will give you positive result given that there is a disease, and that probability is given as 9 by 10. Now from this we can definitely say that the diagnostic test will give us negative given that disease is there, and will be 1 minus 9 by 10, which is 1 by 10. Okay, they have to sum up to 1 because there is like a diagnostic test can either give positive or negative. That's what we will assume here. And it is also given that the diagnostic test will give positive result if the disease is not there, D complement, which means if the disease is not there, then the test will give positive with the probability 1 by 10. So another set of probabilities given are probability of positive given that disease is not there is 1 by 10, and similarly the probability of getting a negative result given that disease is not there is 9 by 10. Okay, so this is what all is given. Now let us look at the question. These are all the probabilities given. We have written that on the scribble pad. Now, if a randomly chosen person tests positive, a randomly chosen person is tested positive. Now we don't know if that person had disease or not. We don't know that, but we definitely know that the test gave the result as positive. What are the odds in favor? Now odds in favor is a new term, so it's mixing up two concepts. Okay, and GATE frequently does that. Odds in favor is something that we have seen in the basics of probability initially. Odds in favor of any event is what? Odds in favor of any event is probability of event upon probability of not happening of event, or ratio. It's a ratio essentially. Okay, so probability of happening of an event ratio is 2 probability of not happening of an event. Of any event you can define odds in favor like this, and odds in against are reverse of that. Odds against an event is probability of not happening of an event is 2 probability of happening of an event. Okay, so what are odds in favor that a person actually has the disease? So firstly let us try to calculate that. Let us try to calculate the probability that the person actually has the disease. Now we have to find the probability that the person actually has the disease given that they were tested positive. From all this data, how do I compute this? Write in the chat. If all these data is given, how do I compute this probability? Bayes theorem, we will apply Bayes theorem, correct. This is standard Bayes theorem question, okay. Okay, cool. So this is standard Bayes theorem question. We will compute this as probability of positive given disease times the probability of disease upon probability of testing positive. Okay, so I'll just use this. Probability of what do we want to find? Probability of disease given positive using Bayes theorem. So probability of disease given positive will be probability of positive testing positive given you have the disease times the probability you have the disease upon the total probability of you being tested positive. Now total probability of you being tested positive will be sum of two things. It will be this plus -1 as well. Probability of positive given you have the disease times the probability you have the disease plus probability of getting tested positive given that you don't have the disease times the probability you don't have the disease. So this is the denominator, overall denominator. Now we have all the terms that we need. Now we'll just substitute probability of positive given disease is what? 9 by 10. And in the class I have solved at least 20 questions on the Bayes theorem, right? We have solved lots and lots of questions, many difficult questions as well. Just revise that if you are still having problems. The ideal strategy is you can create a tree. Okay, if you want I can do that here as well. Let me do that. So 9 by 10 into probability of having a disease is 1 by 20 upon 9 by 10 into 1 by 20 plus probability of testing positive given that you don't have a disease is 1 by 10. So 1 by 10 into probability of not having a disease is, if the probability of having a disease is 1 by 20, probability of not having a disease will become 19 by 20. Okay, 1 minus this. So we will use that 19 by 20. Now this 200 will be a denominator in all three of them. It can be taken common and cancelled out, and then hence this probability will become 9 upon 9 plus 19, which is 9 upon 28. This is the probability, but probability is not asked in this question. See what, here there was no option as 9 by 28. If there had been an option, most of you might have made that mistake. But they are not asking the probability, they are asking the odds in favor. They are asking the odds in favor. So if you have calculated the probability, odds in favor of any event is the probability upon 1 minus the probability, which means 9 by 28 is to 1 minus 9 by 28, which means 19 by 28. So that odds will become 9 is to 19. And similarly, odds against will become 19 is to 9. Okay, the reverse of that. And hence odds in favor of having a disease is 9 is to 19, which is option C. So the free course will be valid till GATE exam, which means GATE 2026 course will be given to you. So till GATE 2026, the course will be there for you, and the test series will also be there for you. Odds in favor अब समझ में आ गया? Okay, any doubts? Then I'll move on to the next problem then. Correct, Ritam, correct. That's the correct formula. Odds in favor is P upon 1 minus P, and odds against is 1 minus P upon P. Okay. Now moving on to the next problem, NAT 1 mark question. NAT problems don't have any negative marking. That's a good thing. But the bad thing is we don't have options. So we'll have to solve it, and we have to write the exact same answer. Now one pro tip for exam, don't try to be a hero. Don't try to test the range. Okay, some people do that. Let's say their answer is coming as 6.5, exact 6.5. They will try to unnecessarily try to mark 6.49 just to check and then claim for GATE exams. Like I was approximately correct. No, don't do that. If you're getting an answer, and follow whatever instructions are given. Generally, if the answer is a floating point number, an irrational number, let's say, okay, if the answer is coming as 22 by 7, then generally in these problems, generally speaking, they will write that round the answer to 2 decimal places or something like that. Okay, so follow that. Like if this number is 3.142857 and so on, what will you do? You will try to round it to 2 decimal places, so it will become 3.14. And if this had been 6, you round it to 3.15. Do exactly what they are saying. Generally speaking, they will give you some bit of range in floating point answers. So if your answer lies between X and Y, it will be correct. But try to do exactly what they are saying. Okay. And if it is an integer, like for example in this question, the number of 3-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 without repetition. It is a P&C question. The answer will be an integer. Write the integer itself. Okay. Cool. And in an integer, it doesn't matter if you're writing 0.0 at the end or not, but why write it? Okay, if the answer is coming as 14, write 14. Okay, it will be marked as correct. Okay. Cool. So the number of 3-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 without repetition, such that the first digit is greater than the last digit is. First digit has to be greater than the last digit. And we have to create 3-digit numbers. We have to create 3-digit numbers. Okay. So if the condition had not been there, that the first digit had to be greater than the last digit, if this condition is not there, then the number of 3-digit numbers that can be formed without repetition is what? Whenever you have without repetition, we can only use one digit only once. So how many options do we have for the first digit? 1, 2, 3, 4, 5. 5 options. How many options do we have for the second one? If one digit is gone, you have 4 options left. So 5 into 4 into 3, which is 60 options. So there are 60 possible number of integers that can be created with this criteria, which means 3-digit numbers. using these digits without repetition. We have solved again a lot of problems like this in class. It is a standard permutation question. You can also write it as 5p3. The number of ways in which we can order 3 numbers from 5 numbers with repetition not allowed is 5p3. That will also be 60. Now they are adding a constraint here. The constraint is first digit is greater than the last digit. First digit is greater than the last digit. Okay. Now there is one very easy way to solve this problem. Very easy way is, see, the problem is like the problem does not give weightage to the first digit and the last digit, right? Like in half of these numbers the first digit will be larger, in half of the numbers the last digit will be larger. Okay, it is saying that it's strictly larger. Okay, we have to take that in mind. Okay, let's solve it completely. Let's not use any tricks. So in how many of these numbers the first digit is strictly greater than the last digit? So let us try to see. Now we have to create 3-digit numbers. We still have to create 3-digit numbers. Firstly, let us try to populate the first and last digit. Then based on that we can populate the middle digit, right? The first task that we want to solve, it's like we will use the rule of multiplication. Rule of multiplication says what? You are given a very complex task T. We want to solve task T1 and then task T2. Task T is what? We want to create 3-digit numbers such that the first digit is greater than the last digit. So task T1 that we will solve is, we will try to firstly populate the first digit and last digit. In how many ways can I populate the first digit and last digit such that the first digit is greater than the last digit? How many possible options can I have? How many possible options can I have? I can enumerate them also. So if the first digit is 2, the last digit can be 1. If the first digit is 3, the last digit can be 2 or 1. If the first digit is 4, the last digit can be 3, 2 or 1. If the first digit is 5, the last digit can be 4, 3, 2 or 1. If you are not able to get any formulas, this is what you can then do. So how many total possible ways for first and last digit do we have? How many possible pair? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 possible pairs. Do you agree? There are 10 possible pairs for first and last digit. This answer has to be 10. There are 10 ways to solve task T1. I have enumerated them all. Okay. Now task T2 is very simple. Once you have already populated the first and last digit, how many options do we have in every such case? Let us say that the first digit is 2 and last digit is 1. That is fixed. How many options do I have for the middle digit? I don't have any constraint. I can populate it using any of the 3 remaining numbers. There are always 3 remaining numbers. If 2 and 1 is gone, 3, 4, 5 are left. So there will be 3 different options I will have here. I can have 3 here, 4 here or 5 here. So I will have 3 options in each one of these cases. So hence the total number of numbers will be 30. How many of you got this? And since you cannot repeat numbers, anyway there will be strictly greater. So, and again the problem is not, problem does not differentiate between a number greater than or a number smaller. So that is another small trick to solve the problem. You can directly say the number of numbers has to be 60 by 2. In half of them, first digit will be higher. In half of them, last digit will be higher. Because you are comparing only those 2 digits. अब समझ आ गया अमन? Please repeat the constraint part. The constraint part is what? The constraint part is the first digit has to be greater than the last digit, right? So in how many ways can I do that? कितने तरीकों से मैं ये लिख सकता हूँ कि 3 डिजिट भरने मेरे को इन 5 डिजिट्स का यूज करके 1, 2, 3 और 4 और 5 मुझे दिए हुए हैं, राइट? 5 मेरे को डिजिट्स दिए हुए हैं, मेरे को ये 3 प्लेसेस भरनी है. अब ये मेरी फर्स्ट प्लेस है और ये मेरी लास्ट प्लेस है. मेरे पास क्या क्या ऑप्शंस है, मैं क्या क्या कौन से डिजिट्स यहाँ पे रख सकता हूँ. और ये दिया हुआ है कि रिपीटेशन अलाउड नहीं है. रिपीटेशन अलाउड नहीं है. यहाँ पे आप दोनों जगह 1, 1 नहीं लिख सकते या फिर दोनों जगह 2, 2 नहीं लिख सकते. रिपीटेशन अलाउड नहीं है. तो अब मैं सारे पॉसिबल केसेस देखता हूँ. अगर मैं फर्स्ट डिजिट पे 1 रखना चाहूँ, 1, तो मैं लास्ट में कुछ भी रख पाऊंगा नहीं, राइट? क्योंकि पहले डिजिट को लास्ट डिजिट से बड़ा होना पड़ेगा, करेक्ट? तो 1 ऑप्शन पॉसिबल ही नहीं है. अगर मैं यहाँ पे 2 रखूँ तो लास्ट डिजिट क्या हो सकती है? केवल एक पॉसिबिलिटी है, 1 हो सकती है. सिमिलरली मैंने यहाँ पे सारे पॉसिबल केसेस लिखे हैं. फर्स्ट डिजिट अगर 2 है तो लास्ट डिजिट 1 हो सकती है. फर्स्ट डिजिट 3 है तो लास्ट डिजिट 2 भी हो सकती है और 1 भी हो सकती है, तो यहाँ पे दो पॉसिबल केसेस हैं। फर्स्ट डिजिट 4 है तो लास्ट डिजिट 3, 2, 1 कोई भी हो सकती है, तो यहाँ पे 3 पॉसिबल केसेस हैं। और फर्स्ट डिजिट अगर 5 है तो लास्ट डिजिट 4, 3, 2, 1 कोई भी हो सकती है, यहाँ पे 4 पॉसिबल केसेस हैं। तो टोटल 10 पॉसिबल केसेस है मेरे पास फर्स्ट और लास्ट डिजिट के लिए, तो ये जो कि मेरे कंस्ट्रेंट को सेटिस्फाई करते हैं। ओके, cool. So that's why the answer to this question is 30. Okay, there are 30 possible ways. Okay, let's move on to the next problem of probability and stats. This is an MSQ question, 2-mark question, but MSQ questions again don't have any negative marking. And here you need to mark all the correct answers which are there. You need to mark all the correct answers. If you mark all the correct answers, then only you will get all the marks, and there is no partial marking. At least in gate 24, 25, there was no partial marking. So it is expected that there will be no partial marking. Okay. So you have to mark all the correct answers as it is. Cool. So let x1, x2, xn be real numbers with mean mu and standard deviation sigma, which is non-zero. So there are n numbers given, x1, x2, xn, and their mean is given as mu and standard deviation is given as sigma, and it is given that sigma is non-zero. Okay. Standard deviation computed with respect to mean with divisor n. Like this is given because they're like for sample variance we use n minus 1. For population variance we use n. So just to avoid confusion, they have given that standard deviation is computed with respect to the mean and divisor is n, which means you have divided it by n. Okay. Now a transform data set is defined like this. A transform data set is created like this. This is the rule for creating a transform data set. So now you are creating n new numbers, y1, y2 up till yn, in which yi, any yi is given as xi minus mu upon sigma plus 5 minus 2 mu. Xi minus mu upon sigma plus 5 minus 2 mu. Okay, so every number is being transformed with this rule. So what does this mean? Let us say the initial numbers were x1, x2, x3, xn. Now you are and this entire sequence has a mean mu and standard deviation sigma. Now you are defining a new sequence. This is your sequence S1. Now you are defining a new sequence S2. In S2, the first number y1 will be x1 minus mu upon sigma plus 5 minus 2 mu. Mu is a constant. See, this sequence is already given. This mu is already given. This sigma is already given. All these, the sequence S1 and its parameters are constant. They are not changing. Now you are defining a new sequence, which means mu is fixed, x1, x2, xn are fixed, which means S2 is created using this rule. So this will be a constant number. It will come out as a number. Whatever value x1 has, let's say 3. And let's say the mean of that, the first sequence is 2. And the standard deviation is 1. Then you can say that if this number is 3, I'm just giving you an example, and this mean is 1 and this sigma is 1, let's say. Then the new number that y1 will be 3 minus 1 upon 1 plus 5 minus 2, which is 2 plus 5 minus 2, which is 5. So the first number will be 5. And similarly, you will create the second number and so on. So this is how you are computing the second sequence. Based on this rule, you are creating the second sequence. Okay. So similarly, the next number will be x2 minus mu upon sigma plus 5 minus 2 mu, and so on. The last number will be xn minus mu upon sigma plus 5 minus 2 mu. Okay, now what is the question asking? ML से नहीं है, ये तो statistics का है ना, probability and statistics है तो आपके subject का नाम. Probability and statistics में statistics तो है ही. तो स्टैटिस्टिक्स में हम पॉपुलेशन मीन, पॉपुलेशन वेरिएंस, सैम्पल मीन, सैम्पल वेरिएंस, ये सब पढ़ते हैं. तो वहाँ से ये ओके, जो कि हमने हमारे कोर्स में मॉड्यूल 3 में कवर किया है. मॉड्यूल 1 में हमने काउंटिंग की थी, मॉड्यूल 2 में प्रोबेबिलिटी, मॉड्यूल 3 में स्टैटिस्टिक्स. वहाँ से ये क्वेश्चन. ओके, So which of the following statements is or are correct? Now, and also let mu y and sigma y denote the mean and standard deviation of this sequence. So for this sequence we are defining, the mu as mu y and the standard deviation as sigma y. We can compute mu and sigma very easily. We already have all the tools for, and the options are which of the following statements is or are correct. Mu y is 5 minus 2 mu, sigma y is something, sigma y does not depend on mu. If sigma is 0, then mu y is still well defined. Okay, so all the options are related to mu y and sigma y. We have to compute mu y and sigma y to answer this. How do I compute? We know the linearity of mean, the law of linearity, right? Like mean is linear, which means that mean of ax plus b is a times mean of x plus b. This we already know. And for standard deviation, what happens? The standard deviation of ax plus b is a times standard deviation of x. B, like it does not vary. Like if you're changing, if you're shifting the entire data by a constant, the standard deviation does not shift. But if you're multiplying the entire distribution by some value, the standard deviation also gets multiplied by the same value. This we have proven like in classes. Everyone knows this thing. For mean, it is strictly linear, which means if you're applying ax plus b to every value, mean also does the same, follows the same. And variance takes the square. So if you're calculating variance of ax plus b, it will be a square times the variance of x. Okay. So variance follows this, and then you take the square root to get the sigma. Okay. So let us use that to compute the mean and variance, or the mean and the standard deviation of the new sequence that we created. So the mean of the new sequence will be what? So what did we do to the first distribution? We created the new distribution like this. The new distribution is x minus mu upon sigma plus 5 minus 2 mu. Now mu and sigma are constants here, and hence the mean of y will be the mean of this entire thing. Okay, the mean of this entire thing, which means it will be the mean of x minus mu upon sigma plus 5 minus 2 mu. Now let us try to break it down. What is happening here? The mean of x by sigma minus mu by sigma plus 5 minus 2 mu. Now mean is linear. Mean is linear, which means if you calculate the mean of this entire thing, what will happen? You will get x by sigma. So that it will just become the mu of x upon sigma, because if you're taking mean of x, it is mu of x, which means the mean of the distribution x, which is mu itself. Okay, don't get confused. The mean of x distribution is mean of all these values. That value is mu itself, and that value is being used here as well. So like it might be slightly confusing, but this mu is a constant. Mu, sigma, these are constant. It just turns out that the mean of this variable x is also the same constant mu. Okay, so mu x is mu only. So I can just write it directly as mu upon sigma minus mu upon sigma, and all of these are constants. They will just be copied as it is. So plus 5 minus 2 mu, and this will cancel out, and you will get 5 minus 2 mu. And hence the average or the mean of sequence S2 or y is nothing but 5 minus 2 mu. If the average of the sequence x is mu, the average of the sequence y is 5 minus 2 mu. If you follow this rule, 5 minus 2 mu. This is the average. So option A is correct. Now we have to calculate the standard deviation. So for standard deviation, let us calculate the variance. Variance follows a square. Okay, it's quadratic and it doesn't matter with linear shift. If you're just shifting the entire data set, variance does not change. Variance is the spread. So spread does not change if you shift the data. But if you scale the data, it gets a squared. So variance of y is the variance of, again, x by sigma minus mu by sigma plus 5 minus 2 mu. Now this will have no impact on variance. This is all constant. This entire thing is a constant. This will have no impact on variance. Now here for the data set, we are dividing it by sigma. We are multiplying it by 1 by sigma. And hence variance will get multiplied by 1 by sigma square. So it will just be equal to 1 by sigma square times the variance of x. Now variance of data set x is sigma square. If its standard deviation is sigma, its variance is sigma square. So it will be 1 by sigma square into sigma square, which is 1. And hence variance of the sequence S2 or variance of y is 1. and hence its standard deviation is also 1. Standard deviation is the positive square root of variance. We already know that, okay? And hence standard deviation of this data set will be 1. Its mean is 5 minus 2 mu. It will be always 1. It does not matter. So the standard deviation of sequence Y does not depend on mu and sigma of the initial distribution. Okay, it is 1 always. Okay, now let us see the options. Mu y is 5 minus 2 mu, sigma y is 6 minus 2 mu. No, sigma y is 1. This option is incorrect. Sigma y does not depend on mu, which is correct. If sigma is 0, then mu y is still well defined. So how many of you marked this option as correct? See, if you see here, sigma y comes out to be 1. You might think that it is a constant. Even if sigma is 0, sigma y, mu y, okay, if sigma is 0, then mu y is still well defined. Yeah, or so, okay, so even if I write mu y is what? Mu y is 5 minus 2 mu. It does not depend on sigma. Mu y is what? 5 minus 2 mu. It does not depend on sigma. So you might think that if sigma is 0, then mu y is still well defined. It is 5 minus 2 mu. We only care about mu. We do not care about sigma. You might think that this option is correct. But no. What will happen? This is a trick option actually. If sigma is 0, will these values will be defined? Even the data set is defined. None of the data points are defined. Think about it. Every data point has sigma in the denominator. So if sigma is 0, then y1, y2, y3 all will be not defined. They will be infinity. They will be not defined actually, right? Like by 0, by 0. If the data points are now not defined, its mean also is not defined. Okay? Then its mean is also not defined. And hence, if sigma is 0, we cannot say that mu y is still well defined because even the data points or the distribution y is not defined in that case. How to check the original question paper? We will post it. We will post the entire question paper as well later. But if you have attempted the paper, you can go on the portal and log in. You will be able to see your rank and you will see the questions, what you have marked and the solutions as well. Okay, moving on to the next problem. MCQ 2-mark question. MCQ 2-mark question, which means it has negative marking. सेम डेटा पॉइंट नहीं होगा ना, मन डिफाइंड ही नहीं होगा. तुम कह रहे हो सेम डेटा पॉइंट होगा अगर सिग्मा 0 है तो. सिग्मा 0 है तो डेटा पॉइंट डिफाइन ही नहीं होंगे. लेट्स से पहली वाली सीक्वेंस है 1 2 3 4 ऐसे कुछ भी और इसका मीन है 2 और इसका स्टैंडर्ड डिविएशन है 1. अब नई सीक्वेंस में बनाने जा रहा हूँ, वहां पे आ रहा है मेरे पास 1 माइनस 2 अपॉन 0, फिर 2 माइनस 2 अपॉन 0. ये सारी वैल्यूज तो डिफाइंड ही नहीं है. हम कैसे कह सकते हैं कि सेम है? डिफाइंड ही नहीं है, राइट? तो डेटा अगला डेटा सेट डिफाइन ही नहीं होगा तो आप मीन कैसे निकालोगे? मीन भी डिफाइंड नहीं है. Cool. Let's move to the next question. It is an MCQ 2-mark question. Again, it has negative marking. A binary event E occurs with the true probability x equal to 3 by 4. A binary event E happens with a probability of 3 by 4. So probability of happening of an event is given 3 by 4 and it is a binary event. So binary event can only take two values, 0 or 1, which means the probability that event takes 1 is 3 by 4, which means the probability that event does not happen is 1 by 4. A prediction system reports this probability. A prediction system reports this probability P, and the score for that prediction system is defined like this. So a prediction system will give us any probability that an event happens. Let's say P is 0.1, 0.2, whatever. But we define a score, and score is defined as like this. If E occurs, then the score of E is, so if E is 1, then the score for E is equal to 1 is 1 minus P square whole square. And if E does not happen, which means if E is 0, then the score for E complement, which means E does not happen, that score is 1 minus P square. This is how a score is defined. What value of P will maximize the expected score? We want to maximize the expected score. So it's a like gambling problem, like we discussed a lot of problems like this in class, how to find the expected values. So if E is 1, this is the score. If E is 0, this is the score. How to find the expected score? Expected score is score takes two values, 1 and 0. So 1 times probability of 1 plus 0 times probability of 0. That's how expectation is calculated for a discrete random variable. Value times probability, and add them up. So it will be 1 times the probability of 1, which means 1 minus P square. Okay, sorry, the probability. Okay, not 1 and 0. I wrote it wrong. Sorry. So the expected value of score is what? The score is this much. 1 minus P whole square. 1 minus P whole square. This is the score times the probability of this happening. Times the probability. Score times probability plus score times probability, right? So what is the probability of this event happening? What is the probability of E being 1? We know the true probability. We already know the true probability. What is the probability that E will be equal to 1? It is 3 by 4, right? So score times probability plus again score times probability. So score is 1 minus P square. This is the score if you get E as 0. And what is the probability of E being 0? 1 by 4. So this is the expected value of score. If you want, I can create the PMF as well. The PMF of score will look like this. The PMF will look like this. So event can happen. So probability of event being 0 and probability of event being 1 is the true probability is given as 1 by 4 and this probability is given as 3 by 4. And if event is 0, then the score is defined like this. Then the score is defined here like this, and here it is defined like 1 minus P whole square, right? So 1 minus P whole square. This is how the score is defined. Now you want to just calculate the expected value of score. So it is like an expectation of a function of a random variable in some sense. And hence the expected value of score will be the probability times the value plus the probability times the value. Okay, so that's what we are doing. Now what do we want? So this is the expected value of score. We calculated this formula. Now they are asking what value of P maximizes this score. So now calculus is included here. What value of P will maximize this score? You can just differentiate it and set it to 0 and then calculate the maxima. For what value of P you will get the maxima. So let us try to first minimize it, like what is it? 3 by 4 minus 3 by 4 times 1 minus P whole square plus 1 by 4 minus 1 by 4 P square. So 3 by 4 and 1 by 4 is 1 minus 1 by 4 times 3 plus 3P square minus 6P minus P square plus P square. Okay, minus 1 by 4 is taken out. So 3 times 1 minus P square plus P square. Okay, correct. So it will become 1 minus 1 by 4 times 3. Okay, so P square. So 4P square minus 6P plus 3. We want to maximize this. Okay, so let me write it in the new slide. 1 minus 1 by 4 times 4P square minus 6P plus 3. Now for what value of P is this maximized? Let me differentiate it and set it to 0. So differentiation of with respect to P will be, this is constant, this will be 0. So it will be minus 1 by 4 times 8P minus 6 is 0 and I am setting it to 0. So I will get P as 3 by 4. So P is equal to 3 by 4 is a value. Okay, it will be either maxima or minima. How do we check it is a maxima or minima? You can check the double derivative. If it is negative, it is a maxima. If it is positive, it is a minima. So if you calculate the double derivative, which means d2es upon d2p, if you again differentiate it, you will get minus 8 by 4, which is minus 2. It is always negative. So this will be a maxima because double derivative is negative. It is a maxima at p equal to 3 by 4. and hence the expected score will be maximum. The expected score will be maximum if the reported probability is 3 by 4, which matches the true probability, which means if the system is giving the probability equal to the true probability of the event, then the expected score is maximum, which means the system is correct. This scoring system is very good. Why am I telling you this? Like, think of it as a business person. You created the system, you should be proud of it, because if someone reports the probability equal to the true probability, then their score is maximum, which means this scoring is very good. I hope you're getting what I'm trying to say. Okay, cool. Moving on to the next problem. Okay, MSQ 2 marks problem. Let x and y be jointly continuous with joint PDF given. Joint PDF of a continuous random variable is given in this question. And we have defined three terms: expected value of x, which is a, variance of y, which is b, covariance of x and y, which is c, and variance of x plus y, which is d. So here you have to make a lot of calculations. Okay, let me be honest. So I'll try to do as much as I can here, and we have to mark which of these are correct. So questions like these generally you leave for the end of the exam, okay? Because once you start solving it, you will see it is like very computationally heavy. Okay, and you should do it only if time is left at the end. And we will not see, like, just by seeing this problem, we cannot see that it is computationally heavy. But yeah, let's start solving it and then we will know. Okay. So let us do that. So the joint PDF is given like this: f of x comma y xy is given as 2 by 3 x plus 2y, where x lies in 0 and 1 and y also lies in 0 and 1. Okay. Now we have to compute, like, firstly, very quickly you can check that this PDF is correct or not. How to do that? The double integral with respect to like x and y should be 1. So you should first, you should not do this in exam. In exam generally the equation will be correct, but just as an exercise you can try to see. You can see that integration from 0 to 1 PDF, which means joint PDF, which is 2 by 3 x plus y dx dy will be equal to 1. Okay, which means the PDF is correct. This is for PDF correctness. Okay, now what do we want to compute? Firstly, we want to compute the expected value of x. The expected value of x. How do we calculate the expected value of x? Expected value of x is what? For a continuous random variable, it is integration of x times f of x dx. For a continuous random variable, it is this, right? For all the values for which x is defined. For all the values for which x is defined, or I can write it like this as well. The general formula is this. For all the values for which x is defined, you do this. Or you can write it as minus infinity to infinity also, but yeah, like x is defined only in a certain range. You can write for minus infinity. This is how expected value is defined. Now here, see, this is the joint PDF and we want the marginal PDF. How to convert a joint PDF to a marginal PDF? Firstly, let's do that. So we need to convert this into a marginal PDF. So I'll do that. So fx of x, which means the marginal PDF of x is you integrate y from minus infinity to infinity or 0 to 1. You just integrate y keeping x as constant, which means integration from 0 to 1, 2 by 3 x plus 2y with respect to y. This will give you the marginal distribution with respect to x, and similarly you can compute with respect to y as well. That will be useful in this question. So it will be 2 by 3 times x y plus 2y square by 2 from 0 to 1, which is 2 by 3 times x plus 1. That's it. 2 by 3 times x plus 1. Okay. So this is the marginal PDF of x. Now similarly the marginal PDF of y, although we don't need it for this option but we might need it later, let me calculate it. It will be integration of 0 to 1 2 by 3 times x plus 2y with respect to x. Again 2 by 3 can come out and it will become x square by 2 plus 2yx from 0 to 1, which will become 2 by 3 times 1 by 2 plus 2y. This is the PDF of y. This is the PDF of y. PDF of x and y is done. So now here you can calculate the expected value of x. It will become 0 to 1 x times PDF of x, which means 2 by 3 times x plus 1 dx. Again 2 by 3 can come out and you will get x cube by 3 plus x square by 2 from 0 to 1, which means 2 by 3 times 1 by 3 plus 1 by 2, which is 2 by 3 times 5 by 9. 5 by 9. Okay, so expected value of x is 5 by 9 and the option is saying a is greater than 3 by 5. First option is saying a is greater than 3 by 5. A is expected value of x. So the value of a is 5 by 9. So is 5 by 9 greater than 3 by 5? 5 by 9 is 0.55, right? It is 0.55. 555 like that. And 3 by 5 is 0.6. So 5 by 9 is not greater than 3 by 5. It is less than 3 by 5. Option A is incorrect. I am just giving you way how to solve it. There is no other way. You have to do this. We will release the response sheet soon. Okay, we will release the response sheet soon. Don't worry about it. Cool. Now we need the variance of y. Now we need b is the variance of y. B is the variance of y. So we'll have to calculate the variance of y. For that, we will need to calculate the expected value of y and then expected value of y square both. So it's a good thing that we already calculated fy, which is 2 by 3 1 plus 2y. Okay, so let's use that 1 by 2 by 3 half plus 2y. So we have already calculated that fy of y is 2 by 3 half plus 2y. Using this, I can calculate the expected value of random variable y. It will be integration of y times fy y dy from 0 to 1 because y is defined from 0 to 1. So integration from 0 to 1 y times 2 by 3 half plus 2y dy. So 2 by 3 will come out. Y by 2. So y square by 4 plus 2y square. 2y cube by 3 from 0 to 1, which means 2 by 3, 1 by 4 plus 2 by 3. Okay, so if you calculate it, it will come out as 11 by 18. It will come out as 11 by 18. And similarly, you can calculate the expected value of y square. Expected value of y square will be integration from 0 to 1 y square times fy y dy. So it will be integration from 0 to 1 y square times 2 by 3 half plus 2y dy. So again 2 by 3 will come out and it will become y square by 2, which means y cube by 3 plus 2y cube, which means 2y to the power 4 by 4, 0 to 1, which means it will become 2 by 3 times 1 by 3 plus 2 by 4. Okay, is this correct? Y square by 2. So y cube by 6. Okay, this value is incorrect. Y cube by 6. I made a calculation mistake, so I'll just fix it. Y cube by 6 and y 1 by 6. So if you calculate it, I have already done it. I'll just use that. It will come out as 4 by 9. It will come out as 4 by 9. And hence the variance of y. And hence the variance of y is expected value of y square minus expected value of y whole square, which is 4 by 9 minus 11 by 18 whole square. So this value will be 23 by 334, 23 by 324, which is around 0.07. So you will use the calculator. Okay, remind me, I'll conduct a video on how to use the scientific calculator given on the portal as well. Okay, like what are the tips and tricks to be taken care of and how to do that. So we will have a video on that as well. So you should use the calculator very efficiently for all these calculations. Okay, so it will come out as 0.07, and the option is asking that is this value less than 1 by 10? Yes, it is less than 1 by 10. Yes, this value is less than 1 by 10, which is 0.1. Okay, and hence option B is correct. Yes, this was the longest question in the whole paper, but yeah, like I just want to finish it. It is hectic, right? Some questions might come like this. Generally in exam they won't ask you all the 4 values, they will ask you only one of them, but I wanted one question to be really exhaustive and want to see how you handle it. Okay, generally speaking, you should leave these type of questions for the end of the exam. Okay, there will be 1 or 2 questions like this definitely. Okay, now C is covariance of x and y. Covariance of x and y, how do we calculate it? Remember the formulas. So what are we given? We already calculated a few values. We calculated a few meaningful values. Expected value of x we calculated as 5 by 9. Expected value of y we calculated as 11 by 18. Now what is covariance? Does anyone remember the formula? Covariance of x and y is expected value of xy minus expected value of x into expected value of y, right? So we just need to calculate this. So expected value of xy can be very easily calculated. It is integration, double integration 0 to 1 xy times fxy xy dx dy. So we'll have to do double integral here. So here 2 by 3 will come out, and integration 0 to 1 xy times x plus 2y dx dy. Now if you calculate this integral, it's not like I'll just give you the direct answer here. Okay, so this will come out as 1 by 3. I want to just save time and I'm just giving you the answer directly. This will come out as 1 by 3, and hence the covariance of x and y will come out as 1 by 3 minus 5 by 9 into 11 by 18, which means that value will be minus 1 by 162. It is essentially negative. This is greater than this. You don't need to calculate the exact value. In exam, you just like the option is saying what? The option is just asking you, is the value of C less than 0? So you just have to check which is greater. Okay. So yes, C is negative. It is minus 1 by something. It is negative, and hence option C is correct. Okay. Now D is variance of x plus y. How do we compute the variance of x plus y? How do I come? This is the most trickiest option. Okay, like this has to be the only question, which this is the only meaningful question here. How do I compute the variance of x plus y? So we can directly use the formula. Variance of x plus y is variance of x plus variance of y plus 2 times covariance of x and y. How many of you remember this from classes? Why use this formula? Because some of these values we have already calculated. Variance of x we have already calculated. Sorry, variance of y we have already calculated. 2 times covariance of xy we have already calculated. We just need to calculate variance of x. That is very easy because expected value of x is also we have calculated. We just need to calculate expected value of x square also. So let us do that. Expected value of x square, let me give you the answer directly, is integration again 2 by 3 times integration of x square times x plus 1 dx, and this will come out as 7 by 18. Okay, and now we can use all these values. So variance of x is 19 by 81 plus variance of y is 23 by 324 minus 2 times 1 by 162. Okay, so this value will be 5 by 36. This value will be 5 by 36, which is very much less than okay, they are asking by 1. Okay, they are asking for 1 by 5. 1 by 5 is 0.2. So 5 by 36 is 0.13. It is 0.13 or 0.14 actually. Okay, 0.14 is not greater than 1 by 5. Option D is incorrect. Okay, we need to do all this. There is no skip for that. And I apologize for this question. But yeah, like sometimes this might happen. Just be mindful that if very lengthy question comes in exam, how to handle it. If you are able to solve some parts of it, see what will happen if you start solving it. If you're like really confident, start solving it. A, B, C you will do, and then you will realize you're just taking more time. Just stop it there. Just write all the key information on one side and move on. And at the end, if time permits, you can jump back to this question. Okay, but it is doable. See what will happen. It might take 8 to 10 minutes, but it's doable. Okay. Cool. So this is like just formula based question from PDF or from continuous random variables. Okay, let's move to the next problem. How many of you were able to solve this in exam? How many of you remembered the law of iterated expectations and law of total variance? We discussed this in detail in classes, right? We proved them for discrete random variable and continuous random variable and solved problems for both of them. It's a very simple problem, but you need to remember all the rules that we know. So write in the chat what should be the answer for this. I think the answer was 12. Lotus. Yes, very good guys. Okay, so most of you did, and that's really nice. We saw this. This is not lotus, right? This is not lotus. Lotus is law of lotus is different. Okay, I forgot the full form. But yeah, lotus was different. Law. Okay, but this is law of total variance. Law of total variance. Law of total variance says that variance of x based on these values. It is obvious that we have to apply lotus here. Law of total variance here. Variance of x is expected value of variance of x given z plus variance of expected value of x given z. Expectation of variance plus variance of expectation, and you apply it on conditional random variable. See, x given z is a random variable. Don't forget that x given z is not a constant. X given z equal to z is a random variable. So for x given z, you calculate the variance, then expectation, and you first calculate expectation and then variance. If you add them up, you will get the variance of the random variable x. Okay. So this is the law of total variance. We proved it in class and we solved a lot of problems on this. Now the tricky part is how do I compute these values? So variance of x given z, is z square plus 1. So its expected value will be expected value of z square plus 1. So it is expected value of z square plus 1. It is expected value of z square plus 1. How do I calculate the expected value of z square? Everything is given in the question. Expected value of z and variance is given. So variance of z is what? Variance of z is expected value of z square minus expected value of z whole square. So this is given as 2. So this is given as 2, which means 2 is equal to expected value of z square minus expected value of z whole square, 1 square, which means expected value of z square is 2 plus 1, which is 3. And hence this value is 3 plus 1, which is 4. So the first value is 4. Now the second value, variance of expected value of x given z, is nothing but the variance of expected value of x given z is 2z minus 3, which means it is 4 times the variance of z. 4 times the variance of z, which means 4 times 2, which is 8, and hence this value is 8. Now 8 plus 4 is 12. Variance of x is 12. Write in the chat if you got it. It is very easy problem. If you remember the rule, it's pretty simple. Okay, moving on to the next problem. This is question number 8 from probability and statistics. Again a 2 marks question. A call center agent handles 45 customer chats. The handling time for each chat is independently and identically distributed, with mean as for 12 minutes and standard deviation as 4 minutes. For each chat, the mean is 12 minutes and the standard deviation is 4 minutes, which means for 45 chats, the mean is 45 into 12 minutes and the standard deviation will be 45 into 4 minutes. Now I cannot write standard, the variance will be, right? Yeah. So the variance will be 45 into 4 square minutes, and hence the standard deviation will be square root of 45 into 4 square. Okay. Cool. Now what is the question asking? Let T45 be the total, like why did I do it for 45 chats? Because we need that. The question is asking about 45 chats. Let T45 be the total time to handle 45 chats. Then using the central limit theorem, approximate probability of T45 less than or equal to 520. What does central limit theorem say? If n is large, then sum of any identically and independently distributed random variables, if n is large, will be approximately normal. Which means that if you are like, see, for one chat, the mean and standard deviation is given. For one chat, it is given. And if you add 45 of them, then it is highly likely that if you add high number of independently distributed random variables, you will get an approximately random variable. You will get an approximately random variable. This will be like for 45 chats overall, it will be approximately a normal variable with mean as 45 into 12 and standard deviation as square root of 45 into 4 square or 16, or you can write it as 4 into square root of 45. Everything covered in class. Anything outside, like anything here is not that we have not covered it. Okay. Statistical inference question, correct. Now, so this is a normal random variable. So it is a normal random variable. Now what do we want? We want to calculate the probability of this random variable being less than 520. So probability of this random variable, this is the random variable T45. We want the probability of T45 being less than or equal to 520. How do I calculate it? If for any normal random variable, if you want to calculate the probability, you just subtract by mean and divide by standard deviation. You make it a standard normal random variable. So it will become probability of T45 minus mu upon sigma being less than or equal to 520 minus mu upon sigma. So T45 minus mu upon sigma will become a standard random variable Z. Okay, it will become Z. So it will become probability of Z being less than or equal to 520 minus mean, which is 45 into 12 upon standard deviation, which is 4 into root 45. Okay. Now if you calculate this value using calculator again, 520 minus 45 into 12 upon 4 into root 45, what does it come out to be? It comes out to be 0.75. Yeah, it comes out to be 0.75. Okay, so it will be just the probability of Z is less than or equal to 0.75. Z being less than or equal to 0.75. Now how do I calculate it in terms of P? How many of you remember P? P is the cumulative distribution function for standard normal random variable. So probability of Z being less than or equal to 0.75. So Z looks like this. This is the distribution of Z with mean mu as 0 and standard deviation as 1. We want to find the probability of this being less than 0.75. Sorry. Okay, I made a mistake here. This value does not come out to be, oh, this value comes out to be minus 0.75. Okay, sorry. This value is negative. Okay, it comes out to be minus 0.75. So it is the probability of, so this will come out as probability of Z being less than or equal to minus 0.75. Cool. So what do we want? We want the probability of this Z being less than or equal to minus 0.75, which means this area. We want this area. What does phi function tell us? It will be equal to, see, phi function is nothing but cumulative density phi of any Z is probability of Z, or like the standard normal random variable being less than or equal to Z. So it is equal to, so that's what this area that we want. This is nothing but phi of minus 0.75. Phi of minus 0.75. This is the answer. But the options are not given in terms of minus 0.75. We know that phi of minus x is 1 minus phi of x. Phi of minus x is 1 minus phi of x. So I can write it as 1 minus phi of 0.75 as well. Now why so? Because phi of 0.75 will give us this entire area. Phi of 0.75 will give us this entire area. And we want just this area. This area is equal to this area. And the total area is 1. Okay, and this green area hence will be 1 minus phi of 0.75. We have solved a lot of problems like this. Once you get into phi area, then it becomes easy. So the correct answer is 1 minus phi of 0.75. Not a very difficult question. Okay. So these are all the probability and statistics questions. Now let us move to linear algebra. Okay, so there were 8 probability stats questions. We solved them all. Now we will move to linear algebra. Total 10 marks linear algebra came. There are total 7 questions. So let us start linear algebra now. So we will take a 2 to 5 minute break, and after 5 minutes we will resume and we will start with linear algebra. So we'll go subject wise, one by one. Okay, so after 5 minutes I'll be back and we'll solve linear algebra problems. Okay guys, we are back. Now let us see some linear algebra problems. Okay, so this is the first problem from linear algebra. 1 mark numerical answer type problem, which means again there is no negative marking. Let A, B, C be non-zero vectors such that A is perpendicular to B. A is perpendicular to C, norm of A is 3, norm of B is 4, norm of C is 12 and B transpose C is 24. Then you need to find norm of A plus B plus C whole square. Very simple formula based problem. Norm of A plus B plus C square will be norm of A square plus norm of B square plus norm of C square plus 2 times norm of A dot B, the dot product of A and B, plus 2 times norm of B and dot product with C, plus 2 times norm of C dot product with A. Now A and B are perpendicular and A and C are perpendicular, which means this will be 0 and C and A are perpendicular, which means their dot product will be 0 as well. And the dot product of B and C is given. So this is not norm, this is just the dot product, okay? Okay. Now the dot product of B and C is given as 24. So you can just plug in the values. So it will be 3 square plus 4 square plus 12 square plus 2 times 24. So what does this value come out to be? 217, right? So 217 is the correct answer. I think everyone must have gotten this right. Okay. So if your problem is over attempting and if your accuracy is really low, try to understand like why this is happening. And while you are analyzing full subject tests, I'm giving you a tip again here, okay? So when you analyze the full subject test, try to see which subjects you are making accuracy mistakes in. And like slowly, like see, you will be giving 10 full syllabus tests as a part of this test series, right? So slowly try to build that, build the muscle memory in such a way that you will know that for this particular subject I am really confident. For example, for linear algebra I never make mistakes, and then you can be like slightly like so like that way tune yourself. And if you're, let's say if you're making a lot of mistakes in machine learning, always like there are accuracy problems, you make MCQ problems wrong. Accuracy wrong is like accuracy low is not a good indicator of how like you don't judge yourself based on that, because one thing, you are attempting all the MSQ and NAT problems. Even if you're not able to get it, you will attempt something, right? Because there is no negative marking. So accuracy does not give you the big picture. The idea is take risk only in the subjects where you are really confident, okay? So that way, like tune yourself, like based on the results of all the tests, you will slowly improve. पोर्टल पे सॉल्यूशन पीडीएफ आ जाएगी, ओके? नहीं, यहाँ पे स्केलर वाला नहीं चलेगा ना फॉर्मूला अमन, वो माइनस तो पहली बात तो होगा ही नहीं, और जो तुम कह रहे हो 3 ABC एंड में ऐड करने का, वो स्केलर्स में होता है, वेक्टर डॉट प्रोडक्ट में तो ऐसे ही करते हैं हम, वेक्टर डॉट प्रोडक्ट तो हम ऐसे निकालते हैं, राइट? नॉर्म ऑफ A plus B. Okay, if you want, you can try to do it on pairs, like take A plus B as a vector and C as a vector. So here what will happen? The norm of A plus B plus C will be norm of A plus B square plus norm of C square plus the dot product of A plus B with C, and that way if you expand you'll get that, okay? Here 3ABC term will not be there. Cool. Moving on to the next problem. Yeah, and that is very good. You can use A plus B plus C dot product with A plus B plus C. Yes. Okay. Okay, again 1 mark question, MSQ problem, very simple problem. Sample space, like whenever vector space is asked, I think everyone is getting them now, right? Vector spaces are very simple. We saw that in very detail. Actually, there are 10 rules to see vector V, C, T, O, R. You don't need to do all of that. Now we all know that a plane in R3, x plus y plus z is 0. So a plane passing through origin in R3 is a vector space. I don't need to check all the rules, do I? If you want, you can, all the 10 rules. Y is equal to 2x plus 1. It is a line in R2, but it does not pass through origin, right? Y is equal to 2x plus 1 does not passes through origin. It passes through like 1 comma 0, 0 comma 1 and minus half. Okay, so it is not a subspace. And V3 is x square plus y square is less than equal to 1, which means in a 3D space, everything inside is sphere. So it will not be closed under scalar multiplication. Why? If you take a point, let's say 1 comma 2, 1 comma 0, 1 comma 0 will be inside the space, will be inside V3. But if you multiply it with 3, 3 times 1 comma 0 will not be inside V3. So it is not closed under scalar multiplication. It is not a vector subspace. Now this is set of all matrices which are symmetric and they have a trace of 1. Trace of 1 means sum of the diagonal elements is 1. So all the set of all symmetric matrices which are symmetric which have a trace of 1. Okay, so yep. Okay, so there is a mistake in the answer key. We will fix it. This is not a subspace, right? Because trace is 1. I think like this is marked as the correct answer, but I don't think it is a vector space. Let me think about it now. So set of all symmetric matrices which are symmetric and which have a trace of 1. For example, if I take two matrices with trace of 1, let's say 1 0 0 0, and if I add them up, like for example 0 0 0 1, so these two are symmetric matrices and they have a trace of 1. But if I add them, I will get a matrix which does not have a trace of 1. Okay, so it is not closed under addition. It is not closed under addition. And also yes, and also it does not contain 0 matrix. Very good. It does not contain 0 matrix and hence it is definitely not as vector space. Option B, C and D are incorrect. In the answer key we have given option D is correct. We will fix it and re-evaluate the results. Don't worry, okay? We will do that. You will get 1 more mark if... Cool. I don't know how I missed it. Okay, so this was question number 2. Moving on to the next problem. Question number 3. Let A be a M cross N matrix. Consider AX equal to B with B being Rn, B in Rm. Assume that A is fixed. Select all the statements that are correct. If M is less than N, then there exists a matrix A such that AX equal to B and that has at least one solution for every vector B. See, at least one solution for every vector B means every vector B lies in the column space of matrix A. AX equal to B has a solution only if B lies in the column space of A. Right, and we are saying that at least, so Ax equal to B has at least one solution for every B, which means that for every B, for every right hand side there is a solution, which means for every B, Ax equal to B is consistent. It means that entire Rm, because B can lie in Rm, right? A is a M cross N matrix, which means that the column space of matrix A has to be entire Rm. There has to be nothing left in the column space. Not a single vector must be there which can be outside the Rm, like the column space in Rm. So essentially the column space has to be Rm, which means you must have at least M independent columns. So we have a M cross N matrix. Every column has M components and there are N columns, which means you should have at least M independent columns, which can happen if N is greater than M. N is greater than or equal to M. If N is less than M, then that can never happen. Think of it this way, right? Very easy. If N is less than M, this can never happen because you cannot have M independent columns and hence the column space cannot be entire Rm. But if n is greater than or equal to m, then this can happen. And in option A, they are saying if m is less than n, then yes, it can happen. If n is larger, then yes, you can have m independent columns, and yes, the entire column space can be Rm. There will exist a matrix A like that. You can construct a matrix A like that. Option A is correct. If m is greater than n, then for every matrix A, there exists some B for which Ax equal to B has no solution. This is also correct, right? Because if m is greater than n, what will happen? You cannot have m independent columns, which means entire Rm cannot be the column space of matrix A. There will be something left, at least one or two, like something will be left, and hence there will always exist at least one vector such that Ax equal to B does not have a solution. How many of you got this? Yes, we said that top 50 will get the test series for free. Top 50 will also get the course for free. Don't worry. Okay, we will contact you. So option B is correct. If rank of A is n, if rank of A is m, then for every vector B, the system Ax equal to B is consistent. If rank of A is m, yes, again, if rank of A is m, it means that it has m independent columns. At least m independent columns and m independent rows as well. Then only rank can be m, right? So it has m independent columns, and yes, then you can say that for every vector B, their system Ax equal to B is consistent. Option C is also correct. If rank of A is n, then for every B, Ax equal to B has a unique solution. We cannot say anything about it. If rank of A is n, then you cannot say that entire Rm is the column space. It might be possible that for some vector, there is no solution also. There might be infinite solution also. There can be anything. Okay, so if rank of A is n, then you can see what can happen. Let's see. If there is a m cross n matrix, for all the columns are independent. Rank of this matrix is given as n, which means all the columns are independent, which means that there are no free columns. There are no free columns. It means that you can never have infinite solutions. Infinite solutions thing cannot happen. You cannot have infinite solutions. But what else can happen? Anything else can happen. You can have zero solution, you can have single solution. 0 or 1 can happen. Okay, so you cannot say that it will always have unique solution. It might have no solution also, because in that case the column space might not be entire Rm. We know, we have solved, like we have seen these type of conditions a lot when in the class. I hope this makes sense. Okay, moving on to the next problem. Let A be the matrix 1 to 1, 2, 1, minus 1. Which vector lies in the null space of matrix A? Which vector lies in the null space of matrix A? Null space means what? Null space of any matrix is the set of all vectors x such that Ax is 0. That's it. You just have to multiply the vector and get the 0 vector. Now you are multiplying a vector with the matrix 1 to 1, 2, 1, minus 1, which is a 3 cross 2 matrix. So sorry, 2 cross 3 matrix. So you can only multiply a 3 cross 1 vector and you should get 0, 0 at the end. Then it is in null space. So it should be a 3 cross 1 vector. So 2 cross 1 vectors are already gone. They can never be the answer. The null space will be a subspace in R3, not R2. So only 3-dimensional vectors you have to check. Now if you check option C, you will get minus 1, 1, minus 1. So if you multiply them, are you getting 0 vector? Minus 1 plus 2 minus 1 0. Minus 2 plus 1 is 0. So this is 0. Option C is correct. And for option D, if I do it again, 1 minus 1 minus 1, I will get 1 minus 2 minus 1, which is 2, and then 2 minus 1, 1 plus 1, 2, minus 2 comma 2, and hence this is not in the null space. Option C is the null space. Only option C is correct. Okay, very easy question. Got it? Pretty easy. Let's move to the next problem. Now next is numerical answer type 2 mark problem. Let A, this is exactly like the problem that came in GATE 2025. We discussed it in class. In the practice session we discussed it. How to solve it, there are multiple tricks to solve this problem. We can use the rank one, we can use the eigenvalues, anything. So let A be a 8 cross 8 matrix, square matrix, and it satisfies A square is equal to 2A. A square is 2A, which means that A square minus 2A is 0, which means that A minus 2I is 0. Now here you cannot say that either the matrix A is 0 matrix or identity matrix. No, because it is not that only the product of 0 matrices is 0 matrix. The mistake that we make is scalar trap. Scalar trap is wrong. You cannot write it as A 0 matrix or 2 times the identity matrix. Wrong, incorrect. From here what we can infer is every matrix satisfies its own characteristic polynomial. So if A square minus 2A is 0, you can also say that lambda square minus 2 lambda is 0, because every matrix satisfies its characteristic polynomial, which means its eigenvalues will also satisfy this equation, and hence the eigenvalues of this matrix will be lambda minus 2 is 0. You can write it for eigenvalues, not for the matrix. Eigenvalues can be written, which means that the eigenvalue of this matrix is either 0 or 2. The eigenvalues of this matrix is either 0 or 2. There are only two possible eigenvalues, and we already know that eigenvalue 0 corresponds to, like, the non-zero eigenvalues correspond to rank. So rank of this matrix is given as 5. Rank of this matrix is given as 5, and it is a 8 cross 8 matrix, which means I can definitely say that the eigenvalues of this matrix are 2, 2, 2, 2, 2, 5 times, because there are only two possible eigenvalues, 2 or 0. So 2 will happen 5 times and 0 will happen 3 times, so that the rank can be 5. Then only rank can be 5, right? Rank is the number of non-zero eigenvalues. So this is the only possible configuration. So these are all the eigenvalues of matrix A. Now they are saying the matrix B is defined like this. So matrix B is A square plus 4I minus 3A, and hence the eigenvalues of matrix B will be, so corresponding to 2 you will get 2 square plus 4 minus 3. You can directly substitute, like the characteristic polynomial, you can just swap it and you will get the eigenvalues, right? Just apply the same equation. So the for eigenvalue corresponding to 2, the eigenvalue of B will be 4 plus 4 minus 3. Okay, I think I made a mistake here. Okay, yeah, this is wrong, right? Eigenvalue of just give me 1 second. 4. Actually, it is correct, right? Yes, it is correct. So eigenvalue of B corresponding to lambda is equal to 2 will be 2 to the 2 square plus 4 minus 3 into 2. Okay, so I forgot into 2. Yep, I forgot into 2. So it will become 4 plus 4 minus 6. So 8 minus 6 is 2. So eigenvalues for B will be 2, 2, 2, 2, 2, 5 times. And for 0, for corresponding to 0, it will be 0 plus 4 minus 3 into 0. So it will be 4. Corresponding to 0, eigenvalue will be 4. So it will be 4, 4, 4, 3 times. And hence the eigenvalues of matrix B are 2, 2, 2, 2, 2 and 4, 4, 4. And hence the determinant of matrix B is product of all the eigenvalues, which means 2 to the power 5 into 4 to the power 3, which means 2 to the power 5 plus 6, 11, which means 2048. Okay, it is correct. I forgot the into 2, that's all. Okay, so 204, it is the correct answer. Like, pretty simple. You can use this trick, the eigenvalue trick, to solve any type of problem like this now. Okay, so here we are using the Cayley-Hamilton theorem. Remember that here we are using the Cayley-Hamilton theorem. Every matrix satisfies its own characteristic polynomial. Moving on to the next problem, let A be a 4 cross 4 matrix with 1 plus 2i as an eigenvalue of A, trace of A being 6 and determinant of A being 25. Which of these statements are correct? It is an MSQ problem. So A is a 4 cross 4 matrix. So it will have 4 eigenvalues. One eigenvalue is given as 1 plus 2i. 1 plus 2 iota. Now every real matrix has complex eigenvalues in complex conjugate pair. We have proved this in class as well. So if 1 plus 2 iota is a eigenvalue, then 1 minus 2 iota has to be other eigenvalue, and the remaining 2 eigenvalues will be something and something. We don't know them yet. Okay, so let us call the remaining eigenvalues as x and y. If 1 plus 2 iota is an eigenvalue, 1 minus 2 iota has to be an eigenvalue. Now trace of A is given as 6, which means the sum of eigenvalues. Trace of matrix is sum of the eigenvalues. 1 minus 2 iota plus x plus y is given as 6, which means that x plus y is 4, which means the sum of the remaining 2 eigenvalues is 4, and the determinant of A is 25. Determinant of A is the product of eigenvalues, which means 1 plus 2 iota, 1 minus 2 iota times x times y is 25. So the product of these two eigenvalues is a plus b, a minus b is a square minus b square. So the product of the remaining two eigenvalues will be 25. So for the remaining two eigenvalues, their sum is 4 and their product is 5. So that's a quadratic equation. We can write that the remaining two eigenvalues will satisfy k square minus 4k plus 5 is 0. This equation, it has sum as 4 and product as 5. Okay, so and hence the remaining two eigenvalues will be 4 plus minus square root of b square minus 4ac upon 2a. So it will be 4 plus minus 2 iota upon 2. It will be 2 plus or minus iota. And hence the remaining two eigenvalues of this matrix are 2 plus iota and 2 minus iota. The remaining two eigenvalues of this matrix are 2 plus iota and 2 minus iota. They have to be. So these are the four eigenvalues of this matrix based on everything given. So what options are correct? 1 minus 2 iota is an eigenvalue of A. Yes. A has a real eigenvalue? No. A has all four complex eigenvalues. Product of the remaining eigenvalues is 5 minus 10 iota. So one eigenvalue is given. They are asking the product of the remaining three. The product of the remaining three eigenvalues. The product of the remaining three eigenvalues will be, we know the product of these two is 5. So it will be 5 times 1 minus 2 iota. The product of these three. So which is 5 minus 10 iota. Which is correct. The product of the remaining three eigenvalues is 5 minus 10 iota, which is correct. Trace of A square. So if the eigenvalues of A are these, the eigenvalues of A square will be square of these, and trace of A square will be sum of those. So the eigenvalues of A square will be what? The square of 1 plus 2 iota and 1 minus 2 iota. So 1 plus 2 iota whole square is 1 minus 4 plus 4 iota minus 3 plus 4 iota, and 1 minus 2 iota whole square is 1 minus 4 minus 4 iota. That is minus 3 minus 4 iota. So it is minus 3 plus or minus 4 iota. These are the two eigenvalues for the first one, and from the remaining one, 2 plus iota whole square is 1 minus 2 minus 1 plus 2 iota plus or minus. Okay, so it will become 1 plus or minus 2 iota. So 1 plus or minus 2 iota. If you sum them all up, did I make a mistake here? So you can check the, okay, let me do it slowly. 1 minus 4 plus 4 iota is minus 3 plus 4 iota. Then 1 minus 4 minus 4 iota. This is minus 3 minus 4 iota. And then here we have 2 plus iota and 2 minus iota. So 2 plus iota whole square is, okay, sorry. Yup. So this one will become 4 minus 1 plus or minus 4 iota. which means 3 plus or minus 4 iota. So 3 plus or minus 4 iota, yes. So these are the eigenvalues of A square, and hence the trace of A square is the sum of all these eigenvalues, which is minus 3 plus 4 iota, minus 3 minus 4 iota, plus 3 plus 4 iota, plus 3 minus 4 iota, which will all cancel out, and 0. And hence trace of A square is 0. Trace of A square is 0, not 14. Okay, option D is incorrect. Okay, let's move on to the next problem. Let A be a n cross n matrix with the singular values lambda 1, lambda 2, lambda r being greater than 0. So there are R is the rank of the matrix A. It is an m cross n matrix. It has a rank of R, and the singular values are sigma 1, sigma 2, sigma r in the descending order. Let G be the gram matrix A transpose A. Okay, which of the following statements is or are always true? Which of the following statements is always true? It is an MCQ problem. Only one option is correct. Okay, so how does the SVD of any matrix look like? SVD of any matrix is U sigma V transpose, where sigma contains the values sigma 1, sigma 2 and so on, sigma r, and U contains the eigenvectors of A transpose A. U contains the eigenvectors of A transpose, and V contains the eigenvectors of A transpose A. And you can do it using any one of them, A transpose A. Let's say G is given as A transpose A. Then you can do the eigen decomposition of G. You can do the eigen decomposition of G, which is like V. Okay, let's forget about it. So G can be broken into V lambda V transpose. Yes. And lambda will contain the eigenvalues of G. Lambda will contain the eigenvalues of G, lambda 1, lambda 2, lambda r and so on. There will be some zeros as well, and their square roots will be sigma. So what are they asking? Eigenvalues of G are sigma 1, sigma r. No, eigenvalues of G are sigma 1 square, sigma 2 square and so on. Not sigma 1, sigma 2. Their square are the eigenvalues of gram matrices. Option A is incorrect. Determinant of matrix G. Determinant of any matrix is the product of its eigenvalues. So product of sigma I squares, not sigma i's. It squares. Trace of G will be sum of sigma I squares, which is correct. Because all the eigenvalues of G will be either sigma 1 square, sigma 2 square, sigma r square and then zeros. Either their squares or will be zeros. And hence trace of this matrix will be sum of all the squares, which is correct. Rank of G is n minus r. No, rank of the gram matrix is same as the rank of the matrix. So rank of the gram matrix will also be r, not n minus r. Okay. So the only correct option here is option C. Any doubt? Pretty easy problem, right? Very like doable, simple. Okay. Okay, so this sums up entire linear algebra. Now we will move to machine learning. Again, let's take a 5-minute break, and then we will be back with the next subject, which is machine learning. I will be solving probability stats, linear algebra, machine learning and aptitude, like the subjects which I can take. And then Sriniwas sir will be live on the same stream, and he will solve his subjects like DBMS, calculus, AI. So we will solve all the questions, don't worry. So let's be back and solve machine learning problems after 5 minutes. Okay, let's start with machine learning problems now. So machine learning was 13 marks in this paper and there are 8 problems. So we'll see machine learning problems now. Okay. So this is question number 1. Assume the simple linear regression model y is equal to beta naught plus beta 1x plus epsilon. Epsilon is the error. Where the usual least squares assumption holds. The following given data is given. The following data is given. X is 1, 2, 3, 5 and the corresponding y is 2, 3, 5, 11. Using the least squares method, compute the estimated slope beta 1. So if you remember the formula, that's good. If you don't, like we have seen the detailed proof in class as well, you can derive it also. But yeah, I will use the formula directly. So the data set given is x, y. X is 1, 2, 3, 5 and the corresponding y is 2, 3, 5, 11. Okay. So we know that how do we calculate beta 1, beta naught and beta 1? Beta 1 is the m, right? We solved the same thing for y is equal to mx plus c in class. So m or beta 1 value. Okay. So m or here it is beta 1 cap is n times summation xi yi. Honestly, I don't remember it. I never remember it. But you should remember it. Okay. It's your exam. N times summation xi square minus summation xi whole square. And similarly, we saw a formula for C as well. Okay. So we can use the formula directly. It's directly formula based. So, or else you can derive it. It's not very difficult. So summation xi yi. So we will need xi yi as well. Xi yi is what? 2 into 1, 2, 3 into 2, 6, 5 into 3, 15, 11 into 5, 55. And hence summation xi yi is 16, 18, 6, 7, 78. Right? And summation xi is 11. Summation yi is 16, 21. Do we need anything else? Summation xi square and summation yi square. So xi square will be 1, 4, 9, 25. And yi square will be 4, 9, 25 and 121. And hence summation xi square will be 39 and summation yi square. Summation yi square I don't think we need. We don't need it. Okay, let's forget about it. So it will be n is 4. 4 times summation xi yi is 78 minus summation xi into summation yi upon n times summation xi square minus summation xi whole square. Okay, so if you calculate it, it will come out as 81 by 35, which is 2.31. Okay, I hope everyone got it. Like pretty simple, like just the formula. You just need to apply the formula, you'll get the answer. In GATE 2025, similar question came. They just gave y equal to mx. That's all. Okay. Okay, moving on. Next problem. A binary classification problem has class label y as either 0 or 1 and 8 binary features x1 to x8, and these binary features can also be either 0 or 1. Okay, so this is how the data set is: x1, x2, x8, and all of them can be 0 or 1, 0 or 1. They are all binary attributes, and the output y can also be either 0 or 1. Okay, assume a generative model. Model is full Bayes, no conditional independence. It is not naive Bayes, it is full Bayes. So no conditional independence is given. For each class y, the conditional distribution, the full definition is given in this problem, okay? So that you don't need to remember anything. For each class y, the conditional distribution probability of x1 to x8 given y equal to y is an arbitrary distribution over all the vector features, which means there is no assumption made. And in model B is naive Bayes, feature are conditionally independent given the class, which means x1 probability of x1 given something, probability of x1 equal to x given y equal to y is independent of x2 being x something else given y equal to y. and hence you can make the naive Bayes assumption here. Count the minimum number of independent parameters needed to specify each model, including the class prior, and compute delta, which is the number of parameters in model A minus the number of parameters in model B. Okay, we know this thing, we know the formula, we have solved this type of question many times in class as well. So how many parameters do we have without naive Bayes? In model A, how many parameters will we have? So how many different possible configurations do we have for x? We have 2 into 2 into 2, 2 to the power 8 different configurations for x. And for each one of them, we will have to calculate for y being 0 and y being 1. So 2 to the power 8 minus 1 parameters for y being 0 and same number of parameters for y being 1. Minus 1 why? Because the last one will be independent, like will be dependent on the remaining ones. If you get the remaining, the first 2 to the power 8 minus 1, the last one, like the first 511 ones, 512 will be 1 minus the sum of the remaining ones. And hence whenever we calculate the parameter, it is 2 to the power 8 minus 1 times the number of classes, which is 2. So this is the number of parameters that we will have for x, and also one for prior, the one for probability of y being 1, okay, because y equal to 0 will be 1 minus y equal to 1, so plus one more parameter for the prior, and hence the total number of parameters here will be 255 into 2, which is 510 plus 1, 511. Now for naive Bayes, the number of parameters will be, all of this will become independent, and hence we will have two parameters for like each one of them, and for 8 classes, for 8 attributes, we will have two parameters. So 2 into 8 is 16, and then one parameter for class prior, which is probability of y being 1. So there are total 17 parameters here. Okay, so here we just need to learn this thing, like probability of x1 being 0 given y being 0, and probability of x1 being 1 given y being probability of x1 being 0 given y being 0. From that we will automatically get probability of x being 0 given x being 1 given y being 0. So this is one, and the other one is probability of x being 0 given y being 1, and so on. So two values we need to learn for x1, two values for x2, two values for x8, and so on. So 16 these one, 16 parameters like this, and one parameter for probability of y being 1. This is all the parameter set that we need to learn, so 17. And hence the difference in the parameters is 511 minus 17, which is 494. How many of you got it in the exam? Pretty easy problem, right? सजेशन दे देंगे लास्ट में, डोंट वरी. Okay, you can keep asking the questions in the chat. Meanwhile answer your doubts as well, like general doubts. Moving on to the next problem, MCQ 1 mark problem. Consider a binary classification node in a decision tree with P being 0.5 for class 1 and 1 minus P being 0.5 for class 0. The probability of class 0 and class 1 both is 0.5. We need to calculate the Gini index and entropy. Gini index formula is what? Gini index is summation for all classes pi square, 1 minus pi square. Sorry. 1 minus summation of pi square, I for all classes. Right? So it will become 1 minus 0.5 square plus 0.5 square, which is 0.5. So that's the Gini. Entropy is what? Entropy is minus summation of yi log pi. Which means if yi is 1, then log pi, and yi is 0, then 1 minus log pi. So plus, actually the overall formula looks like this. Plus 1 minus yi log 1 minus pi, right? This is what we do, and by default the base of log is 2. So if so it will become minus for class 1 it is 0.5, so minus log of 0.5 plus log of 0.5 base 2. So if you calculate it by using base 2, the answer will come out to be, okay, log 0.5 is minus 1. So minus 1, log 0.5 is 1 by 2. So again, is there a mistake in the options? Oh, sorry, not y. Here we will have pi, right? So we will multiply it with probability as well. I forgot to multiply it with probability. So this will be multiplied with 0.5 and this will also be multiplied with 0.5. Yeah, now it is correct. So it will become minus 1 by 2 minus 1 by 2. Half into 2. Half into 1. Okay, still 1 plus 1 is 2, right? Let me write it again. Oh yeah, I made a mistake. Log 2 half is minus 1 only. Correct. Yeah, it was correct. Okay, I made a calculation mistake. The formula written was correct. So entropy will be minus of 0.5 into log 2 0.5 plus 0.5 into log 2 0.5. And hence it will be minus, so this is correct. So 0.5 into log base 2 0.5 is log base 2 half, which is minus 1. So it will be minus 1 plus 0.5 into minus 1, which is 1. So entropy is 1 and Gini is 0.5. Okay, the options are actually very simple. Even if you make a slight mistake, you will get it. Okay. Cool. Option B is correct here. Any doubts? Yeah, it is correct. Cool. Let's move to the next problem then. A data set has 5 points in 2D. A is 0, 0, B is 0, 3, C is 4, 0, D is 4, 3, E is 8, 0. We perform agglomerative hierarchical clustering starting with each point as its own cluster using single linkage, complete linkage, average linkage. If multiple cluster pairs have the same linkage distance, merge the pair whose cluster label set is lexicographically smallest. Which of the following statements is or are correct? The statements are: in single linkage, the first merges A with B. In complete linkage, the first merges A with B. In average linkage, the first merges C with D. In single linkage, the next merges CD with E. Okay. So very simple problem actually. Like we just need to calculate distances and it will be done. So let us find the distance of every point with every point. Points are A, B, C, D, E. And the points are A, B, C, D, E. I will calculate distance square. Or let's calculate the distance itself, okay? So 0, 0, 0, 3, 4, 0. Let me write the points. 0, 0, 0, 3, 4, 0, 4, 3, 8, 0. It is a symmetric matrix. The distance of a point with itself is 0. And A with B, the distance is 3. A with C, the distance is 4. A with D, the distance is 4 square plus 3 square, square root 5. A with E, the distance is 8. B with C, the distance is 5. B with D, the distance is 4. B with E, the distance is 8 square plus 3 square, square root. So 64 plus 9, 71. 73. Right. 8 is, sorry, B with D. So 8 square is 64 plus 9, 73. Yes, square root of 73. Then C with D, the distance is 3. and D with E, the distance is 4 and 3, 5. Okay, sorry. I think I missed something. C with D, the distance is 3, and C with E. Yeah, C with E I missed 4. And D with E, 4 and 3, 5. Okay, so this is the distance matrix. Now what do we want? We want single linkage. In single linkage, firstly, like, what is the lowest distance? The lowest distance pair which I see is 3, 3. 3 is the lowest distance. So ideally you should be merging A and B, and we should be merging C and D. Correct? And based on the tie breaking is what? Tie breaking is lexicographically smaller. Lexicographically, whatever is smaller, you will merge that first. So firstly, using any linkage criteria, single, complete, average, doesn't matter. Single and complete average comes when you already have merged clusters, then you will see. So firstly, you will always merge A and B for any of the criterias. A and B will be merged first. In single linkage AB, in complete linkage AB, and average linkage also AB. In every linkage criteria, you will first merge A and B. Because when you don't have any clusters, it doesn't matter which criteria you're using. Now you will see the criteria. So firstly AB will be merged, then CD will be merged because of the distances. Now in option D, they are saying in single linkage, after the first merge, the next cluster that merges with CD is E. So in single linkage, what will happen? Now you have AB and CD and E. So single linkage will see the distance between all the pairs. So the distance between AB and CD is what? The distance between AB and CD is the minimum distance between AC, AD and BC, BD, which is 4. So the distance between these two is 4. And the distance between AB and E is what? 8. And distance between CD and E is also 4. But again, using lexicographical order, we will merge AB and CD first. Using lexicographical order, we will merge AB and CD first, and then we will merge with E. We will not merge CD and E first. We will merge AB and CD first because that distance is smaller. So option D is also incorrect. Any doubts? Simple, like algorithmic. Like, you don't need to do the entire merging. Just the distance graph is enough to answer everything. Okay, moving on to the next problem. What is the primary purpose of validation set? What is the primary purpose of using a validation set during model development? So we have seen 3 types of sets: training, validation, and testing. Right? What is training set used for? To train model parameters. Always remember this. I am just telling you again. Validation set is used for what? For hyperparameter tuning, right? Model selection. If you have multiple models, which model to select, and hyperparameter tuning, both of them. So model selection and hyperparameter tuning. So this can be done multiple times. This is used again multiple times. Testing dataset is used only once. Overall evaluation of the model. It is an unseen data. It is completely unseen. Validation data is seen for model, but testing data is not seen. So what is the primary purpose of validation set? Tune the hyperparameters and select the best model configuration. Option B. Okay. This is the best possible option here. Okay, so let's move to the next question. A single neuron performs binary classification with sigmoid activation. Sigmoid activation is also given. So nice, right? In exam, it will not be given. This is basic level test. That's why I have given it. In advanced level, I will not. Okay. So single neuron performs binary classification with sigmoid activation, which is this. And this is how we calculate it. Given x, wb, true label y as 1, compute the binary class, calculate the binary cross entropy loss. So firstly, let us calculate the z. So z will be w transpose x plus b, which means it will be okay. So it will be w transpose. So actually they should be given as column vectors, but we know how to solve it. Okay, they should be ideally be given as column vectors so that we can calculate it directly. But yeah, let me write it directly. 0.4 the first weight times the first input, second weight which is 0.2 times the second input which is -1 plus b which is -0.1. So this is z which is 0.8 plus 0.2 minus 0.1 which is 0.9. This is z, and hence the sigmoid y hat is sigmoid of z, which is 1 upon 1 plus e to the power minus 0.9. So this is the sigmoid value. Now what is the binary cross entropy loss? It depends on what is the true label. True label is 1. So since the true label is 1, the binary cross entropy loss is minus log y. Minus log y. So it is minus log base 2. Again, by default base is 2. So here we used yi log p. Yes, correct. I made a mistake there. There we have to multiply with probability also, but I made a correction there, right? So that question is also solved correctly. Then Gini index, it is correct. Here we use yi log pi. So that's what I've done here. And what is the default value of our log base, which I have given in class? ln or 2? By default we have used ln, right? If you remember. In class, by default we have used ln, not 2. In again, there we have used 2 by default, and here we have used base e by default, or ln, when we calculated binary cross entropy loss. Generally speaking, this will be given in exam. Okay, so I will make this question a bonus for you if you want. But yeah, like in BC, in decision tree, I have discussed it very clearly. By default, if you are saying binary cross entropy loss, the log base that is used is ln, which is log e. So if you use the default values, here you have to use ln. And when we are calculating in like the entropy in Gini index, for entropy, the by default the log base is 2. Okay, so here we will use ln. So minus ln of and there is a very easy way to remember as well, like in okay, let's forget that. Okay, so for binary cross entropy loss, we will use ln as the base or e as the base. Cool. So if you just calculate this value, it will come out as 0.341 approximately. So you can round it to 2 decimal places, and the correct answer is 0.34. Any doubts in this problem? I did, like, again, I would want the exam, like, see, 90% in the exam they will give you the base. Okay, but if they don't give, for cross entropy loss function, use ln or e as the base by default. And for entropy is generally calculated in bits, so use 2 as the base by default. If you use 2 as the base, the answer is in bits, right? The entropy is in bits. And here we will use e. Okay, here also we can use 2 and the answer can be in bits. But yeah, sigmoid doesn't matter, right? Yeah, that's why I didn't say that. Okay, let's leave it. Okay, moving on to the next problem. Consider standard PCA using eigen decomposition. Eigen decomposition algorithm, like PCA can be done using eigen decomposition or using SVD. We have seen both the algorithms in class. Very simple algorithm. On a centered data X, firstly we have to center the data. We know why we have to center the data. I very recently took this class, so those who took our class must remember the algorithm, right, by heart. With a target dimension K, filling the blanks. Covariance matrix is what? Covariance matrix is 1 by n x transpose x. Okay, so option 1 or 4 will be correct. And C, and then you eigen decompose the matrix C. You eigen decompose it, V lambda V transpose. Then you will get V, and you will pick the top k eigenvalues from lambda and the top k eigenvectors from V. That will make U. So the matrix of principal direction U is what? The top k eigenvectors of matrix V, columns of V for largest k eigenvalues. So option 1 is correct. Any doubts? This is the easiest question. And it is, yeah. Cool. Any doubts? Very easy. Moving on to the next problem. Directly the algorithmic question. We have seen this multiple times. Like the algorithm, we have seen it in detail with time complexity, everything. Consider a linear soft margin SVM with primal objective. So this is the primal objective for SVM. Which statement about the regularization term is correct? What is the regularization term? This is the regularization term. Half W square. We add it. Why? So as the model weights don't grow too much. Okay. So regularization is always done because so as the model weights don't grow too much. Half W square penalizes misclassified points directly. No. Increasing C increases the importance of marginal maximization. No. The regularization term controls model complexity by encouraging smaller W. Correct. So it is like the regularization term, and it will try to minimize the weights as well. Okay. Removing the regularization term always improves generalization. No. Okay. It is not correct. There is no direct correlation. Okay. It generally is seen that if you regularize, you will generalize well. Who will take DSA? Sriniwas sir will take DSA. Okay. Cool. So this actually ends all the machine learning. How? Option C. So which option do you think is correct? See, option A says that half W square penalizes misclassified points. So misclassified points are not penalized because of half W square. They are penalized because of sigmas. Right? Half W square actually minimizes the weights so that the weights don't grow too much. Increasing C increases the importance of margin maximization. No. Increasing C actually handles the training error, right? It increases the importance of training error and not the, and actually it doesn't matter option B is correct or not. It is incorrect actually, but it doesn't matter. They are asking which statement about the regularization term is correct. So C and sigma actually don't, the regularization term is not C or sigma. The regularization term is half W square. So option A and B can never be correct. Option C is saying regularization term controls the model complexity by encouraging. Very simple, right? Yeah, that's what regularization means. That's what it does. And removing regularization completely, it does not improve generalization. What it will do, it will increase overfitting. It will, if you remove the regularization term, you will have overfitting. Why not B, sir? If we increase the C, then then also we have to decrease our margin. Yeah. No, but then it does not. But okay, anyway, it does not concern the regularization term. Does this make sense? C increase or decrease, it does not influence the regularization term. That's all. C is infinity and C is 0, then what happened? Like, it doesn't matter, right? Again, they are asking about the regularization term and it controls the model complexity. That's all. Why? Got it now? Okay. Cool. So these were all the problems of machine learning. Now, next up we have aptitude. Okay. So let's take a 5-minute break again. Take a break, do some exercise, and we will be right back with aptitude problems. And this is the last subject that I am taking after the aptitude. Sriniwas sir will be live and he will take the remaining 4 subjects. Okay. So be right back. Okay, so let's discuss aptitude problems now. Aptitude is the only subject in GATE exam for which the weightage is known. For GATE DA, for GATE CS, mathematics is also known. For GATE DA, we don't know mathematics, any marks can come, but for aptitude is known. Like 15 marks aptitude will come, 5 marks, 5 1 mark question and 5 2-mark question. And there will be no MSQ or NATs, there will be only MCQ problems in aptitude. Okay, so same thing will be followed in the test series as well. Yeah, it happens. Okay, silly mistakes, like you can't avoid them. 1 or 2 will happen in actual exam also. Okay, you will feel so bad. Okay, it will always happen. But what you can do is try to stay focused and try to minimize them. That's all. Okay, let's start. MCQ 2 marks. Firstly, 2 marks problem. The percentage profit earned by selling an article for 2548 equals the percentage loss incurred by selling the same item for 1380. So let us say that the item was bought for X. The base price of the item is X. Then the percentage profit earned by selling it for 2548 will be what? The percentage profit will be 2548 minus X upon X. This is the profit, or in percentage it will be into 100. And that percentage is same as the loss incurred when you sell the same item for 1380, and the loss when you sell it for 1380 will be X minus 1380 upon X into 100. And from here you can calculate the value of X, assuming X is non-zero. So X will come out as 3928 upon 2, which is 1964. So that is the base price of the item. At what rate should the article be sold to make 25% profit? So to make 25% profit, it should be sold at selling price for 25% profit is like 1.25 into X, which is 1.25 into 1964. So you can calculate it using the calculator. It will come out as 2455. Very simple problem. Okay, option B. Any doubts? Okay. Moving on to the next problem. Find the ratio between the fourth proportion to 3812 and the third proportional to 68. Now these are not very standard terms. We added this problem specifically so that you know them. Test series is for these things. Now if you see it once, you will remember it for the exam, right? Generally not everyone knows it. The fourth proportional, and it's a very basic term actually, not everyone might remember it, but yeah, in class, in very 6th, 7th or 10th class, there we used to see these ratio proportions. Okay, so the third proportional, fourth proportional is not that difficult. So the fourth proportional of any numbers is what? You can directly calculate it like this: 3:8 proportion to 12 is to X. Then X is the fourth proportional. And if you need the third proportional to two numbers, then it will be 6:8 proportion to 8 is to X. Then this will be the third proportional, because only two numbers are given. Okay. So here X will become 3X is 3 by 8 is 12 by X. So 3X is 8 into 12, which means X is 32. Here 6X is 64, which means X is 32 by 3. We need the ratio between these two, which means 32 is to 32 by 3, which is 3:1. Option D. Any doubts? Pretty simple. If you know this rule, this is called fourth proportional. This is called third proportional. You can remember it now like this. Okay. Okay, let's move to the next problem. Robert walks a certain distance and rides back, taking a total of 27 minutes. So this is the distance that Robert walks, let's say. Always draw the diagram. So if he walks this distance and then rides back, the total it will take 27 minutes. So let's say the time taken while walking is TW and time taken while riding is TR. Then TW plus TR is 27 minutes. He could walk both ways in 40 minutes. So 2 times TW is given as 40, which means TW is 20. which means TR is 7 minutes. How long will it take for robot to ride both ways? So to ride both ways, the time will be 2TR, which is 14 minutes. Pretty simple, okay? With the easiest question of the paper. Okay, moving on to the next problem. Visual aptitude, very important. Okay, sometimes people make a lot of mistakes in visual aptitude. Just try to see the pattern, see it for two, like try to focus, like what's happening here. Try to see the difference in the images. You will be able to get it. Okay. Generally, one question from visual aptitude always comes in exam. Okay, observe the following figures given and select one option which will continue the same pattern followed by these images. So what is happening here? If you look closely, what is happening? The first image is going down and then a new shape is coming. New shape is random, we don't care about it. So the first image which is there, and it is happening clockwise. So again the first shape comes down and a new shape comes up. Again the first shape is what? First shape goes left clockwise and a new shape comes up. Again the first shape goes up clockwise and a new shape comes up. Now again the first shape will go clockwise, triangle will come here. So equal to circle, star, triangle, circle and arrow will be there, and here a new shape might come, anything. This is the answer and this is in option D. Right, and no other option has this. So if you just follow the pattern, you will get it. Okay, this is what is happening, right? Anything else happening here? No. Okay. Moving on, 121 cubic centimeter of copper is drawn into a wire. What is the volume of wire? Volume of wire is a cylinder. So it is pi r square L. And it is 121 cubic centimeter is given. So the volume is given as 121 centimeter cube. And 1 mm in diameter, which means pi radius is point. We have to calculate it into centimeter, right? Because that is centimeter. So this also has to be calculated in centimeter. In centimeter, it is 0.5 centimeter. 0.5 mm radius. So radius is 0.5 mm, which is 0.05 centimeter. So pi into 0.05 square into L is 121 centimeter cube, like we can remove it. Okay. And hence we will get the length of the wire in centimeter. So length of the wire in centimeter will be 121 upon pi into 0.05 whole square. Okay, so you can use pi as 22/7 here to make the calculation simple, and this will come out as 15400. No doubts, very simple problem and direct answer. Okay. Okay, moving on. In a bowl, there are 8 blue, green. This is probability question. We are master in probability, right? Grade D students. So we want all the probability questions in aptitude, don't we? But it don't happen. There will be at least 1 or 2 counting on probability question. It might come. So in a bowl, there are 8 blue, 6 green, and 7 red balls. One ball is picked at random. What is the probability that it is neither red nor blue? Neither red nor blue means it has to be green. So probability of it being green is 6/8 plus 6 plus 7, which is 6/21. So yes, so 3 2s are 6, 3 7s are 21. So 2/7. The easiest question again. Okay, moving on. English question: tyrant, ruler, disciplinarian. So tyrant is a rude ruler. Rude, matlab this is a behavior. So tyrant means a rude. Ruler is what, like the king. So a rude king is tyrant. So it is a behavior of a king, and disciplinarian is what, like the one who disciplines. Again, it is a behavior of a teacher, right? Driver does not discipline you. Actually, driver don't discipline us. Policymakers might. Servant doesn't. Okay, so teacher is the best option. If you remember the words, then it is okay. If you don't, then you'll not be able to do anything. That's what for GATE. Like I don't want you to stress too much about English. It is like completely like if you've seen the word before, it's fine. If you want, like you can brush up some of the words from dictionary, like the best, like the top words, and do that. But yeah. So banquet, carnival, ravenous, and merrymaking. So dictionary meanings of banquet, carnival, and merrymaking are same. They all are used for a feast, which means a party. Like when you want hosting a party and you're hosting a feast. But ravenous is like something else. It is used for hunger. This means hunger. It is different. Okay, and option B is correct here based on the word meanings. Okay, next we have a passage based question. Passage may always do one thing. I've seen like a lot of times this helps in passage. I'll give you a tip here. This will be a very long passage, okay? Like a lot of things is mentioned in the passage, and then the question is name the feel good hormone. So try to search for the feel good hormone. Where is it mentioned? Where is the feel good hormone mentioned here? Here you will see name. Nowhere it is mentioned. Feel good hormone was mentioned. If you read carefully, you'll find it in 1 minute. Okay, here it is mentioned. Feel good hormone, endorphins. Direct answer. Directly it will mention like this. It might be, or it might be mentioned in the similar sentences, like the one above, one below. Most of the times, the answer comes like in using the local thing. If you see the passage and find the relevant terms, even if you don't read the passage, you might be able to answer it. But yeah, that is not suggested. Generally, like this type of question might come, but sometimes you might have to read the entire passage to make the meaning of it also. Okay, so it depends. First look, you can, if the question is very simple, it's looking like this, then you can answer directly by just taking a look at the passage. Otherwise, you have to read the passage thoroughly. Okay, cool. So endorphins is the correct answer here. It is directly mentioned in the passage somewhere. Okay, moving on to the next problem. A company's annual revenue is 1000 lakh rupees and its annual expenditure is 80 lakh rupees. Quarter-wise revenue distribution is given in pie chart 1. So 108 degrees is for Q1, 72 degrees is Q2, 90 degrees is Q3. So the pie chart has some mistake. Okay, this is 2 times. Q4 is also 90 degrees. So Q1 is 108 degree. 101 upon 360. Like firstly, let me calculate the revenue for every quarter. So into 1000 lakhs. So it will become 300. For Q2, firstly I am doing revenue. Okay, for Q2 it is 72 degree upon 360 into 1000. So it is 200. And for Q3 it is 90 upon 360 into 1000. So it is 1 by 4, it is 250. And for Q4 it is also 90 upon 360 into 1000, which is again 250. So this is the revenue for every quarter based on the pie chart. And so revenue shares are proportional to these angles. The company's annual expenditure is split by category and given in the pie chart too. Okay, so marketing is 72 degrees, cloud is 90 degrees, miscellaneous 54 degrees, salary is 144 degree. And the overall annual expenditure is 800 lakhs. Now what are they saying next? The marketing spend over the year is also given. The marketing, just the marketing one. There are 4 categories here. And they are saying the marketing share is again split into quarters like this. Assume that quarter-wise total expenditure is proportional to the quarter-wise revenue. Revenue and expenditure follow the same trend. That is also given. Expenditure shares all across quarters equals the revenue share across the quarter, which means you can calculate the expenditure also. So expenditure also we can calculate. using the same graph. So in Q1 it will be 0.3 using the same proportion, 0.3 into 800 lakh. So 240 lakh. These are all in lakhs. Okay. So for Q2 it will be 2.2 into 800. So 160 lakhs. For Q3 the expenditure will be 0.25 into 800, which is 200 lakhs. And Q4 it will be 0.25 into 800. So again 200 lakhs. And overall marketing expenditure is what? Overall marketing expenditure is 72 degrees. So overall marketing expenditure is 72 upon 360 into, what is the marketing expenditure given? Total expenditure is 800. So overall marketing expenditure is this much. 72 degrees is what? 0.2. So 160 lakhs. This is the overall marketing expenditure. Now what are they asking? Assume, so this, like, we have calculated everything which might be needed. In which quarter is the marketing expenditure as a percentage of the quarter's total expenditure? Now we have to calculate the marketing expenditure per quarter also. So it will be like marketing expenditure per quarter is what? In Q1 it will be 0.15 into 160 lakhs. In Q2 it will be 0.35 into 160, because total marketing expenditure is 160 lakhs. In Q3 it will be 0.25 into 160, and in Q4 it will also be 0.25 into 160. So I generated these images using ChatGPT, that's why you shouldn't. Okay, but yeah, actually the values are correct. Like this is like just it is repeated twice, it doesn't matter. Okay, cool. So these are the split marketing expenditures per quarter. Now what do we want? Marketing expenditure as a percentage of the quarter's total expenditure. So now we have to divide it by quarter's expenditure. We have to divide this by quarter's expenditure, which means how much it will be. First quarter expenditure is what? 240, 160, 200, 200. 240, 160, 200, 200. So you should calculate all these four values. Whatever is highest, that will be your answer. Right? Which quarter has the highest of this? So if you calculate these values, they will come out as 10%, 35%, 20%, and 20%. So it will be highest in Q2. So whatever is given in the question, keep on doing that using pie chart and whatever. This is data interpretation question. When you're given pie chart, bar graphs, analyze them. Okay. As an ML engineer, again, you should not have problems with these. It's just that they might be lengthy sometimes. That's all. Okay, so this ends all the aptitude questions as well. So we will take a 5 to 7 minute break and we will start with DBMS now. And stay on the same video. Sriniwas sir will come and he will start with DBMS questions. Okay, thanks guys. This is all about my subject for GDMT-1.
ठीक है सर. Hey guys, good morning to everyone. Let me know if you hear me properly. All right. So it's done till aptitude. Okay. So we have given 7 questions from DBMS and warehousing, out of which approximately 3 are from warehousing and 4 are from DBMS, right? So let's start. This is the first problem. So it's like numerical type, 1 marks. So no negative marking in numerical type questions. So it's an easy one. Functional dependencies is given. A relation R is given with 4 attributes. A relation R is given with 4 attributes, and few of the functional dependencies are also given along with that. And we need to find the total number of, like, how many candidate keys are there for this relation. Total number of candidate keys are available for this relation based on these functional dependencies. So it's like not a very difficult problem. So how do we calculate these sort of problems? Are like candidate key is basically a set of attributes using which you can uniquely identify as the row from that relation. Okay, so idea is simple. We like total 4 attributes are given to us. Total 4 attributes are given: W, X, Y and Z. And a candidate key can be a subset of these 4 attributes. So total number of subsets that are possible based on these 4 attributes are 2 to the power n minus 1. We are reducing 1 because it's like 1 is the empty set. Total subsets are 2 to the power n and 1 is the empty set. So there can't be a specific set which is in which like no attribute is present. So we are just discarding that specific set out of total subsets available for these 4 attributes. In this case 4 would be like n would be 4. So we can have total 15 possible subsets, right? So let's write it down. So there can be subsets of 1 attribute, 2 attributes, 3 attributes, or all 4 of them, right? So starting with single attribute, it can be W, it can be X, Y or Z. Only 4 possible, like only 4 possibilities are there if we are talking about total number of subsets out of these 4 attributes in which each subset is having only 1 column. Second, combination of 2, we can have there is a candidate key possible like which can have like say w and x, two attributes at a time, taken two attributes. It can be wx, wy, wz, xy, xz and yz. Right. Taken three at a time. It can be a combination wx, y, wx, z, xyz and wyz. So four combinations we can have, like total four subsets, taken three at a time, taken three attributes at a time, and finally like taken four all together. It is also a possible candidate key. Okay, so now idea is to find the candidate key using these functional dependencies. So we will see starting from single attributes. So the method is to form the closure of these attributes using these functional dependencies. A closure is basically denoted by, like if we talk about what would be the closure of attributes if w is given to us. If w is given to us, what would be the closure? Closure is the set of all attributes that can be uniquely identified just by using this attribute, which is w in this case. So functional dependency is like we have a dependency w to x. So if we have w, the functional dependency says you can uniquely identify a row like with x value if w is given. So from w we can have w, it's a like a trivial sort of closure. Attribute is like can be identified by itself. So like you can add it or remove it, it's like up to you. But from w we can get x. From w we can get x. And now if we have w and x, we have one more functional like a property. From w and x we can also get y. So y would also be in the closure set of w, correct? And if we have y, from y, z is also, we can uniquely identify. So we will also include it in the closure. So a specific set, a specific subset would be a valid candidate key if the closure contains all attributes. In this case, from w we can uniquely identify all four attributes, which is we can also say that using w we can uniquely identify a specific row in this relation, and this is what the candidate key, the definition of candidate key is. Somehow you can uniquely identify the row. In that case it would be a valid candidate key. Okay, so it's a valid candidate key. So in these sort of questions, we have to find all possible valid closures, which will give us all set of like all four like or like total available columns in the relation. That's it. So we already get w as the set of w as a valid candidate key. Okay. Now all of the subsets, all of the supersets which already include a valid candidate key will itself a valid candidate key. So no need to like calculate them again. So we can cancel them out, whichever has this w, because if you add any extra attributes, like anyway you will, w will already give you the unique column involving all the attributes. Okay. So now we left with either x, y, z or combination of these supersets of these x, y, z. Okay. Next is let's check x plus. Let's check the closure of x. If we have x, is there a functional dependency which says given the value of x, we can uniquely identify the remaining set of columns? Let's check it out. The first one should include w, but we do not have, so y can't be reached, so we cannot use the first functional dependency. Second, if we have x, this is also can't be used, and third we can't use third, because there is no functional dependency which is starting from X and giving us some set of attributes. So it is not a valid candidate key. So we will discard X. Similarly, we will check for Y. We will check for the closure of Y. From Y we can get Z. So it will include Z. Then what else? If we have Y and Z, can we get few other attributes? The answer is no, we can't. So this is also not a valid candidate key. So this is also discarded. And similarly, if we have Z, there is no functional dependency which is starting from Z. So Z is also discarded. So all these three are discarded. Then other combinations. So if these three are discarded, there can be a possibility that a combination of these attributes might give us candidate key. So like idea is to check the exhaustive list of total subsets possible, right? Otherwise we'll commit a mistake. Next is XY. So can we get few other attributes if we have XY? From XY we can get X, we can get Y. It is like a trivial relationship. And from Y we can get Z. That's it. So W we can't uniquely identify W using just X and Y. So this is also not a valid candidate key. Why? Because W is missing. Clear? Make sense? So this is also discarded. Same holds for XZ. If we have X and Z, no, we can't get anything. And same holds for Y and Z. If we have Y and Z, from Y there is a functional dependency giving Z, but we already have Z, so this is also discarded. And the last is if we have XYZ. Then also W is not reachable. W is not included. So this is also discarded. So only possible candidate key for these functional dependencies in a relation having 4 attributes W, X, Y and Z is 1, which is W. The answer is 1. Clear? Any confusion? And this is like it can be like increasing the number of functional dependencies, increasing the number of attributes. Rather than 4 we can have 5 attributes. It will just increase the complexity, but the overall method remain the same. We have to find the closure, either a single attribute or a combination of attributes which can give us all possible, like all attributes, which is like in layman terms we generally say that from W X is reachable, but the correct explanation is we can uniquely identify X using attribute W. W should be unique in order to get X. So if only this functional dependency is given to you, W to X, and only 2 columns are there in this relation, it's W X. So if this functional dependency is true, if it's a valid functional dependency, then there can't be more than 1 columns having same value of W. It will be incorrect. It will invalidate the fact that W to X is a valid functional dependency. So if, for instance, if you have 1 and A in A, 2 and B in X, 3 and B in X, this is correct. This is still holding this functional dependency W to X. But as soon as you repeat the value of W, say 3 and A, this functional dependency won't hold anymore. Right? This is the meaning of functional dependency. If W to X holds true, then using value of W you can uniquely identify X. In this case there is a conflict. There are 2 values of W which is giving you different values of X. So which will you map? Right? So this is the overall funda for calculating the count of total candidate keys. right? Shall we move on to the next one? Any confusion in this? Okay. This is from warehousing, specifically a technique in data mining, and like you do not have to know this technique in order to solve this problem. It's a direct straight away problem which is based on market basket analysis. So you might have seen in retail stores and shopping malls near like cash counters, there are certain sections where some sugar candies and chocolates are like they placed deliberately in order to like catch the eye of the customers who are waiting in the queue for making the payment. This is what it is. If you are purchasing two items, what are the chances that you will also pick some other set of items which are related to them? This is known as market basket analysis. You make a basket of similar items X, Y, and Z such that if a customer is purchasing X, there are chances that he will also pick Y or Z. Okay. So the problem says a retail store performs market basket analysis on 2000 transactions. 2000 transactions to discover buying patterns in order to identify that what is the buying pattern to form a basket in order to increase their sales. So this is the observation that they had. Items at XYZ appears in 180 transactions. So out of these 2000, 180 of them consist of X, Y, and Z items. Then X and Y are sold in 300 transactions and Z alone sold in 400 transactions. The association rule under evaluation is if we have X and Y, then how likely is that the Z item will also get sold? This is what the association rule is. Right? And we need to compute the confidence of this rule and report the answer in as an integer multiplied by 100. The confidence that if you sell X and Y, what is the probability that Z will also be sold using this pattern of sales? And like it's like you can use basic probability also in order to identify, but specifically when you talk about market basket analysis, there is a concept like this association rule generally are written as antecedent to consequent. Selling this, how likely is these items will also get sold? And for that we generally calculate the confidence, which is also you can also term or like you can also frame it as probability. Okay, so straight away confidence that if you sell X and Y, Z will also get sold. We need to calculate this, and this is like not that difficult, it's easy. It's that support of X, Y, Z divided by just X and Y, and this support is the probability. Like out of 180 out of 2000 transactions, they are sold in a single basket, which is, if you calculate this, it becomes 180 divided by 2000 whole divided by support of only X and Y are sold and not like excluding Z, which is 300 divided by 2000. A basic probability problem, but yeah, like it is also related to the data mining. So it's just 0.6. If you multiply it by 100, it will be 60. Right? Easy? Okay. Any confusion in this? Anyone? The answer is 60 for this problem. A 1 mark integer type problem. Just multiply the final confidence that we get by 100 to like enter it in a integer value. This is interesting, and similar problem we GATE asked this year as well in 2025. It says we have a sales table. A sales table is there which has 4 columns: year, region, category and amount. This is on OLAP query. The problem is on in warehousing. And we have discussed this in class as well. We have discussed roll-up queries, we have discussed cube queries and few other queries. Okay. So it says that we have a table, sales has 4 columns: year, region, category and amount. For specific year 2024, we need to return the total of exactly these levels. We need some aggregation of this type. We need aggregation on this level for year 2024. So which query is correct? And this is MSQ, like multiple answers are correct. Multiple answers are correct. And in order to mark these answers correctly, you should know how these aggregation works, roll up, cube and so on. How these aggregations work. For instance, let me give you an example. If you have, let's take only these two these two columns, region and category. We have region, and we have category. Let me denote region by R and category by C. Right? So consider only 2 columns. So these aggregations work in this way. We can have multiple regions, we can have multiple categories, and there will be different rows in this table or relation sales based on region and category. Let's say there is a specific region A and a category 1, and we also have sales. We need to give total amount. Amount or sales. So if at a certain instance, I'm taking a subset of snapshot of these sales in order to just explain how these queries work. Okay, so you have A1 and amount say 10. Then you have A, same region A, category 2, amount is 20. Region B, category 1, amount is 5. Region B, category 2, amount is 15. Let's assume you have a specific snapshot of data like this. Now in order to aggregate, you can perform aggregation either based on both region and category, specifically only on region, only on category, or combined both. Aggregate all of them. Aggregate all of them. If you do an aggregation only based on region and category, then we need to take all possible combinations, all different unique combinations of region and category. For instance, here all unique combinations are A, 1. This is one combination. A, 2 is another combination. B, 1 is also a combination, and B, 2. So if you only aggregate based on region and category, these are the 4 columns, these are the 4 rows that will be there in the result. Now if you want to aggregate just based on region, so there are only 2 regions, so aggregation just on the basis of this attribute region will give you 2 rows, A and B. A and B. For that, value of category will be null because category is varying for a same value of region. Just the amount will get aggregated. So for A, the amount will be 10 plus 20, which is 30. For B, the amount would be 5 and 5 plus 15, which is 20. And the row in the aggregation will look like this: A, null, 30, and B, null, 20. Is this clear? Is it clear? And same you can aggregate based on category as well. For category, you have to like aggregate category 1 and category 2. It is like similar to having a group by clause on a specific attribute. You have to group similar items of a specific attribute. That's it. And have an aggregation. An aggregation function, I guess it's sum. For all the queries, we have region, category, and sum of amount. Aggregation would be sum. They can also ask some other aggregation function rather than sum, but in this case, we have to give sum. Right? Okay. So this is how aggregation works. So in this case, we need to have 4 aggregation. First on region and category, this will have all unique combination of R and C. Second, only based on region. So all other attributes we will aggregate, and we will only consider the rows in the result which is having unique regions, then unique categories, and then this is aggregation over all the attributes. You take sum of all of them, and this will give you a single row. This will give you a single row. In this snapshot, it will give you null, and you aggregate all the amount 20 plus 10, 30, and 20, 50. It will give you this. Okay. So this is first part of identifying how these in understanding how these aggregation works. Now the second part is to understand how these queries work. Roll up and cube, they work in a different manner, which is the combinations of the attributes that are passed in them. In both the queries, region and category is passed. In both the queries, for roll up, R and C are passed. So what it will give? Roll up doesn't take all possible combinations, all subsets of these. Roll up works differently, but cube takes all possible combinations. So if you see the result of cube, R and C, this will aggregate. First aggregation will be done on R and C. First aggregation will be done on R and C. Second aggregation will be done on R alone. Third aggregation would be done on C alone. And fourth aggregation would be all aggregated. Q works like this. It takes all possible combinations of the total attributes that you are passing inside it. In this case, we are passing region and category. It will take all combinations. This is what we need. We need for region, we need for both region and category, we need for region, for category, and final aggregation of all. Right? And second, so like option 2 is a valid answer. Option 2 is the right answer. But roll up is quite different. Roll up is different. Roll up doesn't give you all possible combinations. Roll up won't give you all possible combinations. Roll up will give you RC. Roll up will give you RNC. So first one roll up will give. Then it will give region R. Then it will give all aggregation. It will skip C. It will skip C. This is how roll up works. From right to left, you keep on removing one attribute at a time to get the total number of records for a roll up. For instance, even if you have like more than 2, if you ask what this roll up will give, if you have say 3 attributes A, B and C, what it will give? First, it will give all combinations of ABC. All rows will be present in the result of this query involving unique combination of ABC. Then you start seeing from right to left and keep on skipping one at a time. Skip C, the next would be A and B. Then skip B, next would be A alone. And then remove A, combined aggregation. This is what the roll up will return you. All records having unique combination of ABC attributes, all records aggregating values of A and B, then A and then empty, aggregating all of them. Right? So roll up will not have this category. That's why option 1 is not the right answer. Option 1 is not the right answer. Then option C. Option C says select these 3 things, which is fine for year 2024. This is also okay. Group by region and category. union all with total grouped only by region. So it only includes first region and category, which is the first query. Then we have a union all, and then second query. Second is group by all, which is fourth. So second and third are missing. So option C is also not the right answer. And finally, option D is correct. It is, we are using directly grouping sets, and we are passing total combinations that we want to aggregate, which is region category, region standalone, then standalone category, and then combined. So this is option 4 is correct. So option 2 and option like B and D are right answer for this problem. And this is like this problem, we like similar problem we have in this year's GATE. So it's important. They can tweak these queries. They can give some like new query, not roll up, not cube, some other queries. So you have to take care like how to deal with these queries if a SQL query of OLAP type is given to you. Clear? Any confusion in this? Okay. It is also from data mining and specifically from data pre-processing. Data pre-processing. So we have a Z-score normalization. We have a Z-score normalization in order to, without changing the relative meaning of data, can we convert the data into a given range? And like it is highly likely that the range is always from 0 to 1, but yeah, it can like the range can be tweaked from A to B as well, so that the data can be unified before passing it to the models on which we need to perform some training using trained data. Okay. All right. So the problem says it's a easy problem on Z-score only. Directly we need to calculate. It says in data mining, Z-score normalization converts a value X into a Z-score using training statistics mu and sigma. Using the mean and standard deviation, we calculate the Z-scores of all data values of all X's. So model was trained with mu as 100 and sigma as 20. Then we have another incoming data. It's an independent data which has mean as 130 and standard deviation as 10. Right? Now for a new record X, two processing pipelines are considered. First is this one and second is the new one. Train one and new one. So you need to give me which statement is correct. So statements are basically comparing the value of Z-score based on two different pipelines. So it might seem confusing, but if you compute Z-score based on this data, like you should know the formula of calculating Z-score. It would be like I don't think they will provide Z-score formula in exam. It's a very basic formula. Just we have to compute Z-score for these two pipelines. So its Z-score is X minus mu divided by sigma. So since we have two pipelines, so there will be two Z-scores, Z1, Z2. For Z1 or Z train, we will be using mu as 100 and sigma as 20. X is 140 minus 100 divided by 20, which is 2. For second pipeline, it's 130, so 10 divided by 10. 140 minus 130 by 10, which is 1. Okay, so Z1 is coming as 2 and Z2 is coming as 1. And straight away the option is pipeline 1 yields a larger Z-score than pipeline 2. The answer is yes. Option 2, no. Both pipelines yield the same Z-score because Z-score are unitless. It is also incorrect. And finally, pipeline 1 yields a negative Z-score while pipeline 2 yields a positive Z-score. This is also incorrect. So just we need to compute the Z-score based on two different scenarios. One, a data which is like already we have trained a model and we have parameters for that, mu and sigma, and some random other data for which mu and sigma are given. Right? Okay. Then the next, this is multiple select. A schema is given to us which has three relations. A schema is given to us which has three relations: employee, works on, and project. The constraint is every employee works on at least one project, like greater than equal to one project, and PID is not null for all relations. And a query is given. Based on the query which is given to us, we need to select which statement is true. Based on the query given to us, we need to select which statement is true. So if you closely see the query, it is select ename from employee where not exist, then a subquery. And this subquery is also using one more subquery, which is select star from project where PID not in this. Where PID not in this. So if you read this query and try to convert it to like a English statement or a statement which is understandable to like normal people, it is saying that we need this and this info. We need this and this info such that it should not exist. It should not exist. And the subquery, we have a like internal subquery as well in this, and the subquery says project P such that P.id not in projects. P.id not in projects. Worked on by E, and E is related to E which is used outside the subquery. E is related to employees, which says there is no project that the employee has not worked on. There is no project such that the employee has not worked on, which is another way of saying that the employee has worked on all projects. The employee has worked on all projects. Make sense? We need to find employee name from employee such that where not exist star from project where PID is not in worked on, which is there is no project that the employee has not worked on, or you can also say it as the employee has worked on all projects. Now if you have successfully decoded this into this, then you can easily choose the right answer. And this is also the division pattern in SQL. This is also a division pattern in SQL or SQL queries. Right? Okay. So which of the following are true? First one is the query returns the names of employees who work on all project. This is exactly what it is. A is correct. The query returns the names of, query is returning the name, e.name of employees who works on all project. Right? Second, the query returns employees who work on at least one project. It's wrong. It is incorrect. We know why. Third is, if there exists a project, then no employee works on, the result of the query is affected. Third is, if there exists a project that no employee works on, if there exists a project in which no employee works on, then the result is affected. The answer is yes, it will affect it, because the query says I want employees that has worked on all projects, and C option is there exists a project that no employee works on. In that case, it will affect the result. It won't include the name of the employee which has not worked on all the projects. So it is affecting the total like the final result. So C is also correct. C is also correct. D is, the query implements a form of relational division. This is correct. It is a division pattern. A division pattern query. A division pattern query of type. A division pattern query of type employee divided by projects. Employee divided by projects, which says I am including only those employees who has worked on all the projects. We only include employees that has worked on all the projects. This is what relational division or division pattern is. Every record is related to all the records. Only include those records from employee who has worked on every record present in the second relation. Right? Any confusion? Any confusion? Any question in this? Okay. Then the next one, it says a file contains 2 lakh records stored as 50 records per data block. Dense secondary index is built on non-key attribute. So this is like we need to have a file contains how many records? 2 lakh records. We have 2 lakh records, then with 1 index entry per record. This is also important, 1 index per record. Okay, we have few assumptions that each index block can store 100 index entries. Each index block, one index block will store 100 indexes. Will store 100 indexes. Then index blocks are not in memory. Okay. An index is stored and searched using binary search. This is also important. Index is stored, and after storing, the search that is performed on the indices is binary search, not a linear search. Right? The question is how many block accesses are required in the worst case to retrieve one record using the index. Using the index, how many searches are required to get that block. Right? Okay, so based on the information that we have, total records and how many indices we can store in the block, we can calculate total number of blocks required. Total blocks required to store index. Total blocks required to store index. How many blocks? Anyone want to chip in? How many blocks? If we have total 2 lakh records and one index block can store 100 indices, and it's given that one index per record entry. We need to create one index for one record. So how many index blocks are required for this case? Correct. It would be 2 lakhs divided by 100, which is 2000, which is 2000. So we need 2000 index blocks. 2000 index blocks. Right? Now the question is, if you are allowed to perform binary search, how many searches are required in worst case scenario? So what is the worst case time complexity of binary search? What is the worst case time complexity of binary search in terms of n? If you are searching in a data structure, array sort of data structure having n elements, what is the worst case time complexity? And also tell what is the best case time complexity for binary search. What is the best and worst case time complexities? Anyone? In binary search, every iteration or every comparison reduces the search space by a factor of 2. By a factor of 2. We straight away check the middlemost element which is present in between. Based on this value, based on the value and the key that we want to search, based on the value which is present in middle and the key, we decide whether we need to continue the search towards the left or towards the right, based on whether the key that we want to search is greater than the middle element. If the answer is yes, we discard the left hand side and only search towards the right, because we know that it is already sorted. That's why we are applying binary search, and this key would be present, if present, would be towards the right hand side, since k is greater than the middle value, right? So every time we are reducing the search space by a factor of 2. So in worst case, if k is not present, if k is not present, in that case we will take big O of n searches, big O of log n searches. And in the best case is big O of 1. The best case is big O of 1. The middlemost element is the key. The best case is big O of 1 and the worst case is big O of log n, which is the key is not present in the search space itself or in the array. Since we have 2000 blocks, in worst case, if the index is not present, it might take log of 2000 base 2, log of 2000 base 2, and we generally take the upper bound, which is the seal of this value, right? So is this the final answer? The answer is no, because the question says how many block accesses are required. So we can create a confusion just by putting this as a valid option, but since it is not there, so option C would be the right answer. Why? Because it is asking how many block accesses are required. This is just to find the index block. Once you have find the index block, one more search is required in that index in order to get the block where the actual data is present. So this additional one is for the block access. And this 50 records per block data is just to create confusion. It is not required. This is just to create a confusion, and option is there for that. Clear? So it will give you 12 searches, specifically 12 searches in worst case. Any confusion? So we'll be able to access our response key. Yes, after like having the solution of like having a thorough solutions, we will release the response key plus all the solutions that like we are discussing, we have discussed in this live. You can check on the portal and compare your solution with the actual solution or the answer. We will release it. Don't worry. Next is, let R and S be two relations, R having two attributes A and B, S, B and A. Let R dash be renamed version of S such that its attributes are renamed to match R of A and B. And some like total number of attributes present in R union R dash R intersection R dash are given, which is 150, 60, and it is given that mod of R, total records in R and total records in R dash are same. So how many tuples, how many rows are present in R minus R dash? How many rows are present in R minus R dash? This is a classic example of inclusion exclusion. You can easily use it and get the answer. This is not a difficult problem. So it is already given to us that R union R dash, using inclusion exclusion, can I say that it is equal to total records in R, total records in R dash minus their intersection, using inclusion exclusion. Using inclusion exclusion, we can say like, and few of the info is given to us, which is this is 150, this is 150, intersection is 60, and it is given that this and this are equal. Let's take it as x. This becomes a linear equation in x. 150 is equal to 2x minus 60. 2x is 210. So what is the value of x? 105. And what is x? This is x. Total records or tuples present in R, which is also total tuples or records present in R dash. Right? This becomes, which is equal to R and also equal to R dash. Now tell me, based on this information, can you calculate what is being asked in the problem? How can we calculate this? R minus R dash, how can we calculate this? Total tuples present in R minus R dash. Total number of tuples present in R minus R dash. Anyone in the chat, how to calculate this? Correct. Venn diagram is a very good approach in order to deal with these sort of problems to avoid confusion. So if you take this R and take as R dash, this is R, this is R dash. We need to calculate R minus R dash. Whatever present in R, but we need to exclude what is present in R dash as well. So this, exactly this we need to calculate. And this is R minus their intersection. Make sense? This is what is R excluding what is present in R dash. R minus R dash. Have a mod. Clear? This we have calculated. This is given in the problem. It's 105 minus 60. 105 minus 60, which will be 45. 45. B. Okay. Any confusion? Anyone? That's all in DBMS and warehousing. So this was like not that difficult based on the problem sets that are already available for GATE TA, this and the last year's paper. Okay, the next is Python and DSA. Next is Python and DSA. Let's take a short break before starting with Python and DSA. Let's take a small 5-minute break. Okay, we'll resume at 12:10. All right. So let's discuss Python and DSA problems. So we had 9 problems from this, 3 1 mark problem and 6 2 marks. Total 15 marks. We have given the weightage since like it's Python is all like also included along with DSA, and the good thing is that the syllabus of GATE DA for DSA is shorter than from CS. So we do not have this DP and greedy algorithms. We only have till trees and graphs. That's it. Okay. The first problem. Consider the following Python code. A code snippet is given. It's recursion. What is the output of the given Python code? Print g of 5 is called. This is g, and the input is given as the parameter is passed as 5. If 5 is passed as parameter, n is 5, and the condition is if n%2 is equal to 0, whether n is even or odd. If it is even, in that case we are just calling f of n. If it is odd, we are calling f of n minus 1. In this case 5 is odd, so this else part will execute. F of n minus 1 will get triggered. N is 5, we will trigger f of n minus 1, which is f of 4. It will call f of 4. It will call f of 4. And this is like just returning the Fibonacci. This is the code for Fibonacci, starting the sequence is starting from 0, 1, 1, 2 and so on. But since we need to calculate f of 4, just see how we will calculate. We need to calculate f of 4. Since like every recursion consists of 2 parts, a base condition and the recursive logic. Recursive logic is again making 2 more function calls with decreasing the value of n by 1 and then decreasing the value of n by 2. Till when? Till n is not less than or equal to 1. We will keep on calling the same function with decremented values. So f of 4 will call f of 3 and f of 2, n minus 1 and n minus 2, and then we need to add them. The final result is summation of f of n minus 1 and f of n minus 2, right? This f of 3 again will call f of 2 plus f of 1. This f of 2 will call f of 1 plus f of 0. Few of the cases will hit the base condition. Whenever n is less than equal to 1, this will hit the base condition. It is equal to 1, it will return n. So this will return 1. This will also return 1. This will also return 0. N is 0 in this case. So 1 plus 0, which is 1, we calculate their summation and pass to the function which is responsible to call these two recursive functions. It will return 1 plus 0, which is 1. So f of 2 becomes 1. F of 2 becomes 1. If f of 2 is 1, we already know this will also trigger 2 more function calls, f of 1 plus f of 0, and we already know the value. The value is 1. This is 1, this is 1, it will return 2. 2 plus 1, it will return 3. 3 is the value of f of 4. 3 is the value of f of 4. So A is the right answer. Any confusion? A is the right answer. Clear? Let's move on to the next one. Again, a code snippet is given. 2 functions, push bits to stack and convert. And if you see it closely, it is just converting the decimal. It is just the code using a recursive function, bits push to stack, in order to convert a decimal to its binary form. It is decimal to binary conversion. Using recursion. Let's see it how. So the first trigger would be convert and the parameter we will be passing is 13. This n becomes 13. In the first function call, this n becomes 13. This 13 will initialize a stack which will be empty initially, and then it will call push bits to stack, another function with the value of n which is passed. This n is 13 and initially this stack is empty. This stack is empty. Now the control will be transferred to this function which is defined above, the convert function, push bits to stack with value of n as 13 and stack as empty. And now this is a recursive function. It is again calling the same function. The recursive part is it is calling this function again with n divided by 2, integral division of n by 2. And the base condition is we will keep on doing it till n becomes 0. We will keep on recursively calling this till n becomes 0. So let's have the call stack. This is the best way to deal with these recursions. Just draw a call stack and step by step identify these recursive calls with the appropriate parameters. First function call will be with n as 13 and stack as empty. Let me denote stack as s. N is 13 and s is a empty stack. N is 13 and s is an empty stack. We will check if n is 0. The answer is no. So base condition will not get triggered, but the value of stack is updated. The value of stack is updated by n%2. N is 13 over here. 13%2. What is the value? 1, right? Mod of 13 with 2 will give you 1. So the stack s becomes 1 at this point. Then the function is called again with half of the value of n, integral division of n by 2. This will call this function which is push, let me call it push with n as 13, integral division by 2, it will be 6, and this is not the base condition. 6 is not equal to 0, so it won't get returned. It will again put, and s was 1 before, this will append n%2 again in the stack on the top of stack which is towards the right hand side. In list, like this is a list in Python, every push element, every append will trigger, every append, this is the top of the list or the stack. So every element every append will insert the element from the right hand side, and every pop will also remove the element from the right hand side. So value of s becomes 1. The next element is 6%2, 6%2 which is 0, and the function is called again by n divided by 2. This will again call push. At this time n is 3 and stack has two elements, 1 and 0. Is it 0? The base condition, answer is no. N is 3, 3 is not equal to 0. So it will again insert one more element in the stack, 3%2. So s becomes 1, 0 and 1 is inserted. 3 is odd. If you take modulus percent by 2, it will give 1, and it will call again. Push is called again with value of n as 1. 3 integral division by 2 will give you 1. At this point s is 1, 0, 1, and the base condition is still not triggered. So this will again append one more element, 1%2 which is 1. S becomes 1, 0, 1, 1, and this push is also called again, but this time n is 0. This time n is 0, which is the base condition. This is the base condition. This will return. This will just return. We are not returning anything. It's just a single return statement without specifying what we are returning. So just empty return. It will return, right? And once this function call is also completed, this will again keep on returning, since there is no other recursive calls after you have appended this. The last statement after append was to call the function again with the smaller value. So this will also return. This will also return, and again this will also return, and finally it will return the value of s. It will return the value of s. It won't return the value of s, it will update the value of s. The value of s after the function, like all these recursive calls are completed, would be 1 0 1 1. This will be the value of s. This will be the value of the list s which was initially empty here, or stack. Right? Now there is one more logic. Bin is an empty string while stack, which is while elements are present in the stack. We are keep on popping the elements, and every push and pop, every append or pop would be done from right hand side. So the pop will be done from right hand side. The first element that will be popped from this list would be 1, then again 1, then 0, then 1, and we are just appending it to a empty string, So every iteration will look like this. First iteration, bin b would be empty string plus the first element popped, which is 1. Then in the second iteration, another element popped, which is again 1. In the third iteration, this 0 is popped, and finally the last one is popped. So if you aggregate the total value, concatenate the final to get the final value of bin, it is 1 1 0 1. It is a string 1 1 0 1, which is the binary of 13, right? And for if you do not know how the pop and append operations are performed on a list in Python, you will mark the incorrect answer, since 1 0 1 1 is also present in the option A, which is incorrect. Correct option is 1 1 0 1 B. Correct option is option B. Right? Any confusion? This is how you will be dealing with recursions. Have a call stack, trace each and every calls. The examiner can tweak exactly this question, and they can ask how many times this push bits to stack is called. How many times push bits to stack is called? What will be the answer? How many times this recursive function is called? What would be the answer if this is the question? How many times? So, and you will definitely get one question or two questions on recursion. In 24 we get a question, in 25 as well there was a question on recursion. So recursion, definitely they will ask a problem. So it should be absolutely clear how to deal with these recursive calls, which is just to trace the call stack in this sequential manner, the way in which recursion is unfolding. No, it is 5, not 4. This is also the first call which is made in this convert function. So push bits to stack is called 5 times, not 4 times. The answer is 5, not 4. The first function call is also this push only, na? Push with value 13 and empty stack. It's 5, not 4. Clear? Any confusion? So these are the silly mistakes. It's you have to avoid these mistakes. They can ask they can any problem can be, any good problem can be framed in recursion. It's a very deep topic. So you have to be very attentive in order to, while solving the problems on recursion. It might seem easy, it might look easy, but it is where the trap is. Okay, next one. So this is from the last section that we discussed in Python, which is file handling and exception handling. A file is given with this dummy data 10 abc 74 xyz and like new line characters, and the file is opened in read only mode. The file is opened in read only mode, data.txt, and then there is a iteration. We are iterating on the file pointer, and there are two ways to open the file. Like this is the one way in which you have to deliberately close the file to avoid losing the data. But since it's the read only mode, so there is no issue of losing the data. But if you are writing it, until and unless the file is closed, the data which is present in the buffer is not flushed to the memory. It is while the code is running, when you open a file in write mode, until and unless we are not closing the file, the data is not stored in the persistent store. It is present in cache. But when this f.close is triggered, at this point, whenever f.close is triggered, whatever present in this file pointer, whatever data is present in this buffer is flushed to the secondary store or the persistent store. Stored or flushed. In the persistent store. So take care of that. You might lose data if we are not closing the file object properly. In case of write, but read is like there's no harm. So we are reading, and initially the file pointer would be just before the first character, and now whatever we are reading, we are converting it to an integer. We are converting it to an integer after removing the spaces. Stripe is just to remove the trailing and like initial and last additional spaces that we have. So we are converting it to an integer and storing it in a temporary variable called x. Right? Whenever, like when we read the first line, which is itself an integer, converting it to an integer and storing it x is absolutely fine. It will be okay. So initially x will be 10, and based on the value of x, whether it is even or odd, if %2 is 0, which is correct, we are increasing the counter by 2, and initially count is a global variable. Count is initially 0. At this instant, when the value of x is 10, count is increased by 2. 10% 2 is 0, a even number, count is increased by 2, else won't execute, and exception will also not get triggered. We are into the second iteration. This is done. Second iteration is ABC. This is a string, and we are trying to convert a string. We are trying to convert a string to an integer. Will it be an exception? Is it okay to convert a string to an integer without throwing an exception? So exactly at this point, when you try this conversion with a string, it will throw an exception. It will throw an exception, and as soon as the exception is thrown, the code which is after the line on which exception is thrown will just get ignored, and we seek for a exception handling module which is after this try, which is just after this try. Whether there is a exception handle block which is handling the exception which is thrown at this instance. Since we are trying to convert a string to an integer, it is a value error. So the exception will be handled properly, and the counter will be increased by 5. And we will go to the next iteration. It is 7. 7, all good with 7. 7 we can convert it to an integer. At this point it will be an odd number, so count will be increased by 1. Next iteration, 4, even 4% to 0, count will be increased by 2. And finally it's XYZ, again exception will be thrown, and this block will get executed, exception handling block. So plus 5 in the counter. Just add and get the answer. It was integer type. It's an integer type problem. So just add 10, 2, 2, 4, 1, 5. It's 15. It's 15. Clear? Any confusion? Clear? So this was on file handling and exception handling. We have already covered all these topics in module 3 of Python. Okay, this is also an interesting problem. This is on binary search, but it is not a correct binary search. It is an incorrect form of binary search. It looks like binary search. It looks like binary search, but if you unfold this step by step, if we unfold it step by step, it is not, it is a faulty binary search. There is an error in this code. We have to call, we are calling this print and we are passing search array, which is already defined a line before, and we are trying to search element 9 or key 9 in this array using this code snippet. So let's check that. So we have this array ARR having 5 elements, 1, 3, 5, 7 and 9. Indices are 0, 1, 2, 3, 4, 0 to 5, right? Now this is called, search is called with key as 9. This is 9 and array is the list that we have. Array is the list that we have. Okay? Alright. So first line is we define two pointers, low and high. 0 and length of array -1. Let me denote it with L and H. L and H. L is 0. L is 0 and H is length of array, which is 5 minus 1, which is 4. The last index, the last element, index of the last element present in the list. Then there is a while loop. We will keep on triggering this while with the condition whether low is less than high. For the first iteration, it is true. Low is set to 0 and high is set to 4. So 0 is less than 4, which is true. This becomes true. Then we have one more pointer mid. We have one more pointer mid. In this case, M would be L plus H, 0 plus 4, integral division by 2, which is 2. So M will be point to index 2. Clear? We are in the first iteration and mid is, or M is pointed to index 2. Next we have a condition. If array of mid, element present at mid is less than key is 9 and element present at mid is 5. So is 5 less than 9? Is 5 less than 9? The answer is yes, it is. If it is, then low is updated to mid. 5 is less than 9, so we are updating this low and low will point to M. Low will point to M. Else won't execute. We are again in this while checking the condition whether at this point after first iteration, just before entering the second iteration, whether my low is less than high or not. What is the value of low? Low is 2. Let me write it here. L for second iteration is 2 and H is 4. No change in H. And M is 2. Whether my low is less than high? The answer is yes, it is. So we again enter the while loop. We will calculate the value of mid again. Using this, new mid would be 4, 2 plus 4 by 2. 2 plus 4 by 2, which is 3. Mid will be shifted to this index. Mid will be shifted to 3. And if mid is 3, then we will again check if array of mid, the element present at index 3 is less than my key or not. Is 7 less than 9? The answer is yes, it is. 7 is less than 9, so again this low will get updated to mid. This low will get updated to mid. Updated L is 3. H will remain the same. We are updating H in the else part and it is not getting triggered because if is the condition in if is true. Clear? Now it's time for the third iteration. We will check whether low is less than high or not. The answer is yes, 3 is less than 4. Low is 3, high is 4. 3 is less than 4. So again the condition is true. We will have to recalculate the value of mid for third iteration. For third iteration, L is 3 and H is 4. 4 plus 3, 7. Integral division by 2, again 3. No change in mid. No change in mid, so no change in this comparison. We are comparing the same value, 7 with 9. Again, in second iteration, we compared 7 with 9. In third iteration as well, we are comparing 7 with 9. The answer is yes, 7 is less than 9. So this if will execute and low is equal to mid. Since there is no change in mid, there will be no change in low. Mid M is 3, low will also remain 3 since M is not changing. So there is no change in the third iteration. No change. In third iteration. No change in third iteration. In third iteration, nothing is changing. Mid is same, low is same. So in fourth iteration, just before starting the fourth iteration, when we check low is less than high, the answer will be yes. And again, we are comparing the same values again and again. 3 is compared with 4, answer is true. If it is true, we are calculating mid. Mid will remain 3. There is no change in mid. There is no change in L. There is no change in H. This is what the infinite loop is. The code will get into an infinite loop. Option C is the right answer. Can you see it? Anyone having confusion why infinite loop? Clear? So this is like general way in order to get the output of these code snippets, and like you will definitely get these sort of problems. They will ask 2-3 problems like this. There will be a recursion, there will be some combination of strings and list operations performed on these like objects and data types, and like you have to deal in this manner step by step logically without like making any error. Great. So the answer is C for this problem. Then you have an array of size n consisting of distinct integers. This is an easy problem. This is just a word problem on sorting. Consider the following statements about common sorting algorithms. Select all correct statements. It's multiple select, 1 mark because it's easy. More than one options might be correct. So in worst case, quick sort runs n square. Yes, it runs. And what is the worst case of quick sort? The list or array is already sorted and you are choosing the first element as pivot. In a sorted list in which you want to sort in ascending order, choose the first element as pivot. So the worst case will be n square. Anyone, how can you avoid worst case complexity of quick sort? Any suggestions how to avoid worst case complexity in quick sort? So there are few more there are few techniques which can be used in order to, there is no guarantee, but since the problem says worst case complexity, but yeah, for regular quicksort it is n square, but using randomized pivot, there is a tweak like the variation in quicksort, randomized quicksort, you can avoid this n square. Read about it. It's a like a beautiful way to deal the worst case scenario. Rather than choosing a specific pivot every time, you choose a randomized pivot. Or randomized quicksort. There are a few more ways. You can take median, you can take middle values, like there are 2-3 variations in quicksort. But yeah, we have seen the problems, we have seen PYQs based just on quicksort variations in GATE CSE. So it's like we won't be surprised if they ask these sort of problems in like for DA as well. We have PYQs for variations in quicksort. Second, merge sort is stable and has worst case complexity n log n. N log n part is correct. And what are stable algorithms? What is a stable sorting algorithm? What is a stable sorting algorithm? What do you mean by merge sort is stable or not? A stable sorting is a technique in which the order of elements are not changed even after you perform sorting if the order is correct. For instance, if a list is like this 1, 2, 2, 5 and say 3. So if this 2 is marked as, let's assume the second 2 is marked as white, after sorting this should be the order 1, then 2, then the 2 marked in white, then 3 and 5. If the relative order of the numbers is not getting changed after sorting, in that case it is a stable sort, and merge is a stable sort. Merge is a stable sort. Third, heap sort is stable by default and runs n log n. N log n is correct, but it is not a stable sort. Heap sort is not a stable sort. Every time you perform sorting, you have to heapify the elements. You have to heapify the elements, and this can change the overall order. The leaf can like reach the head or the root, so it is not stable. Heap sort is not stable. Last is if the input is already sorted, insertion sort runs in big O of n. Is it correct? Best case insertion sort, is it linear? Is it linear? Insertion sort for best case. It is linear, correct, it is linear. So it's a easy problem, not a difficult one. That's why 1 mark problem. Next is, okay, this is on Master's theorem. A recurrence relation is given of the form, like how will you identify whether a specific problem can be solved from Master's theorem or not? If the recurrence looks like this, T of n is equal to a times T of n by b plus a function which is having a form like this, n to the power c log n to the power k, log n to the power k. If this is the form, if the recurrence looks like this, then you can apply Master's theorem and straight away find the tight bound of this recurrence. And like vaguely you can also compare it with upper bound or lower bound. All are equal. If you calculate the tight bound and you know the tight bound, it is equivalent to the upper bound or the lower bound. Big O or big omega or big theta, all are equal if T of n is of this form, and you get the result using Master's theorem. So this is of the form Master's theorem where f of n looks like this, n to the power c log n whole square. And there are different cases in Master's theorem. This case specifically, to identify which case it lies for Master's theorem, it is, we need to calculate, which is log a base b. So in this case a is 2, b is also 2, c is 1 and k is 2. a2, b2, c is 1, n to the power 1 and log n whole square. So k is also 2, right? Then we calculate this alpha, which is log a base b. In this case it's 1, and we compare it with c. We compare it with c, and there are two cases, either alpha is greater than C. If this is the case, then this term dominates the overall complexity. If alpha is equal to C, then it's combined, and if alpha is less than C, then the second term f of n or whatever it is, it dominates the overall complexity. And the dominance is all about which either the first term or the second term is having a higher power for a very large value of n, which will overpower the other term for a larger value of n. For instance, if in a specific case, if T of n, the time complexity is given as big O of n cube plus big O of n square, in that case this will definitely, for a very large n, when n tend towards infinity, this will overpower this n square. So the upper bound would be n cube, not n square. So this is what the different cases of Master's theorem is all about. Seeing the value of a, b, c and k, you can directly calculate or give the value of the time complexity. Right? So which case it is? Which case it is? It is the case when alpha is equal to C. This is the case when alpha is equal to C. If alpha is equal to C, then the decision is made on the value of k. The decision is made on the value of k, and this specific case is called as polylog case. It's the polylog case. It is the polylog case and identified by the value of k, whether k is greater than 0 or not. Based on value whether k is greater than 0 or not, there are two cases, if I remember it correctly. Whether k is greater than 0, I need to check that, like whether it is compared with 0 or 1, but any of, whether it is 0 or 1, k is 2, so it is greater than that number. You can verify, and then, or like you can tell me in chat what exactly is this k, to identify which sub case of the polylog scenario of Master's theorem is applicable in this case. So the time complexity of this recurrence T of n when alpha is equal to C would be big O or theta of n to the power C or log a base b, both are equal, log n to the power k plus 1, log n to the power k plus 1, and here it is theta n to the power C, C is 1, n log k is 2, so it's log n whole cube. This will be the time complexity of this recurrence. Right? Okay, so once we get the time complexity of recurrence, once we get the upper bound or tight bound or lower bound, it can be anything, but like the most correct way is to say Master's theorem give us theta of n, theta of tn, which is the upper bound. Master's theorem gives not upper bound, tight bound. And since this function is the tight bound of this recurrence, it is also the upper bound and it is also the lower bound. So if a multiple choice question comes given theta and it says is it equal to big O, is it equal to big omega, you should mark it yes it is, because if it is tight bound, it is also an upper bound and it is also a lower bound. Okay, then we have another function g to compare the recurrence or to compare the time complexity which we are getting from Master's theorem. Options are T of n is equal to theta of n log n whole cube. The answer is yes. We get it from Master's theorem. Second, f of n is equal to theta of g times log n. This we need to check. G of n is n log n multiplied by log n, it's n log n whole square. F of n is n log n, it's equal, this is equal to f of n. So yes, B is also correct. F of n is equal to tight bound. F of n is equal to theta of gn times log n. Option C, f of n is equal to big O of gn. What is g of n? G of n is n log n, fn is n log n whole square. G can't be an upper bound of f. G can't be an upper bound of f. C is incorrect. G can't be an upper bound of f. for a very large number, and you can calculate it like this, like whenever you face a confusion whether it's an upper bound or not, we have a short technique. You have f of x divided by g of x and have a limit where n tending towards infinity. If if the limit is tending towards infinity, in that case g is not upper bound. If this limit is tending towards 0, in that case yes, g for a very large number, for a very large positive number, when n is tending towards infinity, g of n is overpowering f of n. In that case it will be 1 upon infinity and would be 0. If this is the case, then g is the valid upper bound of f. If this is the case, then g would be a valid upper bound of f. But yeah, since these are like small functions only, you can straight away check n log n, compare with n log n whole square. Put a very large n, say n is equal to 10 to the power 10 to the power 5. You will straight away get the answer that this is larger than this. So if f is greater than n for a very large number n, then g can't be an upper bound of f. It will be, the value will be below the value of f. So C is incorrect. And finally, for epsilon s1, f of n is omega n square. If epsilon is 1, it is omega n square, and f is n log n log n whole square. Is it correct? Is it correct? Tell me. Is n square a valid lower bound of n log n whole square? Is n square a valid lower bound of n log n whole square? Again, check with, say, this number, a very large number. If it is n square, n square is greater than this, so this is also incorrect. N square is a valid upper bound, but n square is not a valid lower bound for f of n. F of n is n log n whole square. Put a very large n, 10 to the power 10 to the power 5 say, and even though you take log n base 10, log n base 10, f of n will give you 10 to the power 10 to the power 5 times log n base 10, 10 to the power 5 whole square, which is 10 to the power 10 to the power 5 plus 10, 10 to the power 10 to the power 5 plus 10. But on the right hand side it's n square, so it is less than n square when n is a very large number. So this is not a valid lower bound. We are talking about whether it is a lower bound or not. The answer is no, it is not. It is a valid upper bound but not a valid lower bound, right? Any confusion? Okay, and like you can also have a formal definition. There is no constant c such that this, for a very large number, this will be less than this. You can't find a c, because multiplying a constant with a function which is growing exponentially, it won't help no matter what constant you take. Okay, next, consider the following pseudocode for inserting keys into a binary search tree. It's a BST with a pseudocode is given and initially the tree is empty. What is the height of the resulting BST if this sequence is added in the BST using this pseudocode? Okay, let's see. Okay, we want to add 30, then 20, then 40, 10, 25, 35, 10, 25, 35, and finally 50. This is the sequence of numbers that we want to add using the pseudocode given, and you have to be very careful. Even though it is written as BST, I can change this pseudocode in such a way that it is no longer a regular binary search tree. Just by changing this inequality, this inequality, I can change that in a correct BST. If this is the case, A, B and C, if this is the case, then B should be less than A and C should be greater than A. But just by changing the pseudocode, I can change this behavior and it will completely change the question. So always go through the pseudocode, the logic present in the question, in order to identify or the correct sequence or how the tree will look like after you insert all these numbers in this sequence. But this case is we have kept it simple. It's a regular BST where if key is less than root, it's inserting towards left, or else it is inserting towards right. and it's a recursive function. Okay, starting with the first one, first root 30, that's it. It will be the root. If root is null, create a node with key 30. A node is created with 30. Now second, this is done. If I have to insert 20, I will check this condition if my root is equal to null or not. It is not null, so it won't create another node, and it will check whether my key is less than equal to the key of the root or it is greater than or equal to. In this case 20 is less than 30, so it will trigger this insert from the left hand side. It will trigger the insert from roots left, right? The next will be 20. After triggering roots left, it becomes null, and if it becomes null, it will create a new node and it will allocate this key which is 20 to that new node. Okay, this is also done. Then it's 40. 40 will be added towards right hand side because this if will be false, but this else will trigger. 40 is greater than 30, it will be towards the right. Next 10, it will check first 30. It will check at this point, insert, like, is my root is equal to null or not? The answer is no, it is not null. It will check if key is less than equal to roots key. If 10 is less than equal to 30, answer is yes. It will move towards the left. It will move towards root dot left. Now it will check again whether my root is null or not. This becomes the new root in the recursive way. Like this, since the variable we are using here is root. This will be the root. If this is null or not, it will check. The answer is no, it is not null. It will check with the key. If key is less than or greater than with the value of the pointer which is called as root in this case. 10 is less than 20, it will trigger to the left hand side. It will insert a 10 towards left, and similarly we can insert the remaining set of elements. 25 would be, first we will come here, then towards right 25 will get added, then 35 is greater than 30, so it will move towards this, and 40 it will check towards its left, since there is no, the left hand side is null or the left child is null of this node 40, it will create one with value 35, and finally it will create add element 50. Now after inserting in this manner, after inserting like this, the question is what is the height of the tree? Height is just the total number of edges. This is a balanced tree, so height will be 2 in this case. Total number of edges from this to this, 1, 2, right? Okay, 2 is the right answer. Give me a minute. Okay. Next problem. This is multi-select question, 2 marks, more than one can be correct, but this is also a word problem, not a very difficult one. If you have a basic understanding of how graphs are implemented using adjacency list and graph traversals, these traversals we have in DSA plus in AI as well. So even if you remember either in DSA or AI, you will be able to solve it. Represents using an adjacency list where vertices are numbered from 0 to v minus 1. Total we have v vertices in this case. We need to select all statements, all correct statements related to the graph traversal algorithms. First is in a graph containing cycles. DFS can either an infinite loop if visited vertices are not marked. Definitely yes. If you are not marking the visited vertices, it will be an infinite loop. Definitely yes. A is the right answer. It will be an infinite loop. Makes sense, right? That's why we use this visited list of visited indices. List of visited vertices. Right? Second, BFS and DFS will always visit vertices in the same order in the adjacency list if the adjacency list is sorted. No matter you're using adjacency list or other form of representation in graph, the order of DFS and BFS will be different. It's a like general question on BFS and DFS. BFS will work level by level. It will work level by level. First it will cover this level, then this level, then this level. It will work in level ordering manner. But depth first search will first traverse this, then this, then this, then this, and so on. It will be like this. The traversal will be like this. So the order will be different, not same. B is wrong. No matter how you are representing the graph, it is irrelevant of the representation. The underlying algorithm will decide the order in which the nodes should be visited. Okay. Third is, in adjacency list of every vertex is sorted. Like if it is sorted, BFS will visit vertices in non-decreasing order of the shortest path distance from the source. Correct. Decreasing order of their path distance. Yes, this is what level ordering is, or breadth first search is. It will traverse level by level, first level, second level, third level, and in increasing fashion, in such a way that if till all the nodes which are present at level n and level n plus 1, still all the nodes present at level n are not traversed, it won't go, or it won't start unfolding the nodes present at level n plus 1. So this is right. C is right. And finally, for a connected graph with V vertices and E edges, both BFS and DFS run in V plus E time, theta of V plus E, time complexity, implement. This is correct. Time complexity is same for both the algorithms BFS and DFS. It's a standard time complexity. Right? So right answer is A, C and D. Okay. Then we have one more. Pseudocode on topological sorting. This is consider the following pseudocode for topological sorting of a directed graph using DFS. We are using a DFS sort of algorithm to implement topological sorting. Topological sorting is a manner, or is a way of unfolding the nodes of a graph, of a directed graph, such that if there is an edge from a node A to B, if there is a directed edge from node A to node B, or vertex A to vertex B, A should unfold first. A should be traversed first, then B. This is what the topological sorting is all about in terms for directed graphs. Right? So DFS is used to implement this, and pseudocode is given. This is the main, which is called first for U1 to 6. For U1 to 6, starting from 1 till 6. The question says the directed graph says 6 vertices. Okay. How many vertices will be pushed onto the stack before vertex 4 is pushed? This is a vertex number 4. So at the point when vertex 4 is being pushed in this stack, how many vertices are already being pushed? This is what is asked. How will we do? It's not that difficult. In this main, we are traversing the vertices in a order. This for loop is starting from U as 1, from 1 to 6. So the first iteration of this main, or the for loop present in the main, would be for U is equal to 1. When U is equal to 1, it will, since U is, it's the first vertex for which we are calling it, it won't be in visited list. Visited will be initially empty. So it will call DFS with 1. It will call DFS with 1 with this node. Right? And DFS is another function. First it will mark U as visited. It will mark U as visited, which is 1. First iteration U is 1. In this first iteration U is 1. It will mark it as visited. Then for each V adjacent to U, 2 and 4 are adjacent to 1. If V is not visited, again it will call DFS. And since it is mentioned that we are forming some sort of a topological sorting, this will be the node that we will trigger first. It will trigger DFS again, and it won't. Yeah, it will again, since V is not visited, this 2 is not visited, it will trigger DFS again. It will trigger DFS again. It will trigger DFS again for 2. Now if we are calling this DFS again for 2, 2 is not marked as visited, it will check all the adjacent node present to 2. Since there is only one node, 2 to 3, it will again call DFS for 3. This will again call DFS for 5. And this will again call DFS for 6. This will again call DFS for 6. And after, since there is no edges which are going outwards from 6, this is where it will end. This is where it will end. And once it is end, we will start pushing these U's in the stack. So the first element will be pushed would be C, 6, then 5, then 3, then 2, and then this 4 will be triggered. This 4 will be triggered after that. So the answer is how many vertices will be pushed onto the stack before vertex 4 is pushed is 6, 5, 3, 2, 4. It will be 4. The stack will be 6, uske baad 5, then 3 and then 2. This will be the stack. So total elements are 4. Right? Okay. And this is before you start with this, before you're traversing with vertex 4, vertex with value or label as 4. Okay. Why not 1? 1 because since there is already 1 is not yet completed, there is one more node, there is one more edge which is going towards 4 from 1, so 1 won't get pushed to the stack. Think about it, it won't get pushed to the stack. 6 is completed, 5 is completed, 3 is completed, 2 is completed, but 1 is still pending. There is one more edge from 1 to 4. That's why. Right? Okay. Let's have a short break. After that, we'll discuss the problems on calculus. Let's have a 5-minute break. Okay, so let's discuss problems on calculus. So we had 7 questions on calculus, 2 questions 2 marks, both MSQs, and 5 questions single marks 1 mark, 3 MCQ and 2 integer type. And calculus is a topic which is scoring, but you might face few problems on Taylor series, on maxima minima, on optimization, which is important. And you will definitely get a problem on L'Hopital. So, but yeah, calculus is scoring, so you should not be losing marks on a subject like calculus until unless it's a very difficult problem for everyone. So the first is MCQ. A function is given from R to R. It's easy. So like how many total points of non-differentiability exist for this function? It's a combination of 3 modulus function, and we already know that if it's a modulus function, the graph of a modulus function, if f x is mod of x, the graph is like this. So exactly at the point it is non-differentiable. Although it is continuous, but it will be non-differentiable. So all the points for which the modulus is 0, x equal to 0, x equal to 1, x equal to minus 1, it will be discontinuous. It will be discontinuous for all the points. Okay, so right answer is C. There will be 3 points. Otherwise, you can also break it in a piecewise function. You can have intervals. You can have intervals x less than equal to minus 1, minus 1, 2, 0, 0 to 1, and 1 to infinite. You can break it and then also analyze, it will be the same. It's a piecewise function, but since we already know how the modulus behaves, we can identify the non-differentiability points directly by checking the points for which it is 0. The modulus function is 0. So, an easy problem. Then one more function to find the domain and range for a piecewise function. And they can form a piecewise function using like by combining 2 piecewise functions f as well. They can give 2 piecewise function f and g. Both are piecewise, and they can ask you to find f of g or g of f. These are also the problems that students ignore and they commit mistake. If a very good problem can be framed by 2 piecewise function and finding a composite f of g or g of f. Okay, but in this case we just have to find the domain and range. Domain is all possible values of x such that it should be defined, and range is for all those values of x, what is the value of y, right? So in this case, if x is less than 2, the domain, like it's a piecewise function. The first part, when fx is equal to square root of x minus 1, this is all the cases when x is less than 2. But since it's a square root, for this specific instance x minus 1 should also be greater than or equal to 0. It is only defined, the square root was only defined for positive numbers, right? So x minus 1 should be greater than or equal to 0, and in this case it should be less than 2. So for first, the domain of first part would be, it should be greater than, that it gives you x greater than or equal to 1. So x should be from 1 to 2, 1 inclusive, it can be 1. If x is 1, it is valid. A 0 inside a square root, it's perfectly fine. Second is open interval on 2, since 2 is included at this point, right? So first part of domain is from 1 to 2. It can't be less than 1. It becomes a negative number inside a square root. Okay. So all the options which are not including 1 in the domain straight away gets eliminated. C is eliminated, B is also eliminated. C and B are eliminated. Oh, B and C are eliminated. Why? Because they are not including 1 in the domain. It's open bracket on 1. 1 exclusive. We need 1 inclusive. 1 can be, 1 is like, X can be 1, it's fine. Y is defined. And in fact, if X is 1, Y is 0. If X is 1, Y is 0. So it gives one more elimination. D is also eliminated since it is not including 0. This is also eliminated. When X is 1, Y is 0. So 0 is present in the range. But in option D, 0 is not present. So just by elimination also you can identify that A is the right answer. Make sense? Or you can go with the traditional way. In order to find the range, you pass y is y as x minus 1, take square y square as x minus 1, have a function of x in terms of y square minus 1, replace, interchange x and y, it will give you y as x square minus 1, and have this range and try to identify what should be the possible values of y if x is from 1 to 2. It will give you from, like, it will be, for this case as well, it will be from 0 to infinity, but the point is 0 is also included. It is not in part D, so D is incorrect. D is incorrect. So this is how you should solve. And most probably, if a problem is given on domain and range, it should be identifiable, or the elimination can be done based on the options available. You can include or exclude some values. For instance, that if you want to exclude option C just by basis of range, A, B and D are only including the values of y which are greater than or equal to 0. You can put y as minus 1 and check whether it's satisfying this function or not. It won't. You won't get any value of y such that you won't get a mapping of y such that there exists a unique C for that, such that it becomes a function from R to R. And one more important thing, in order to deal with these functions, in function definition, it is written as the function is defined from R to R. The function is defined from R to R. The function is defined from R to R, and this R is codomain. This R is called the codomain, and codomain is not equal to range. And if codomain is not equal to range, what you will call the function if range is not equal to codomain? Give me in chat. Or like, identify it, think it out. Okay, next, limit. And yeah, you can get a similar problem in exam. It's limit, they will ask, definitely there will be a problem on limit. Either from Taylor series or from L'Hopital, there will be a problem. But this can be solved either by both ways. You can have L'Hopital or Taylor series. Have the Taylor expansion of ln1 plus x. ln1 plus x when expanded using Taylor series is x minus x square by 2 plus x cube by 3 minus some polynomial function which is having a degree higher than 3. It would be minus x4 by 4, but we do not need it. We can have it big O of x to the power 4. Some polynomial having higher degree than 3. This will cancel out since x is tending towards 1, and the maximum degree that we have over here is x cube. So any degree which is greater than 3 over here would be 0, since x is tending towards 0, and this is a 0 by 0 form, so we can apply L'Hopital as well. But if you use Taylor series expansion, it gives you, it will give you x minus x square by 2 plus x cube by 3 minus some function minus x plus x square by 2 whole divided by x cube. This x will cancel from this x square by 2 will cancel from this. It's x cube by 3 divided by x cube will get cancelled, and this will be, you can take common x cube from this, but there will be a factor of x, and x is tending towards 0, so it will become 0. It will become 0. There will be a factor of x after dividing this by x cube, so it is equal to 1 by 3. after taking limit x tending towards 0, put x as 0, it will give you 1 by 3. So p is 1, q is 3, p plus q would be 4. And you can anyway apply L'Hopital. If you want to apply L'Hopital, you can apply it's 0 by 0 form. Take derivative of ln 1 plus x, it will be 1 by 1 plus x minus 1 plus x square, derivative would be 2x divided by 2x whole divided by 3x square. Take remainder, it will be 1 minus x plus x times 1 plus x whole divided by 3x square. This 1 and 1 will get cancelled. This x will also get cancelled. It's 1 plus x divided by 3x square. No, it won't cancel it. We have to expand it first. It's x times 1 plus x. After expanding it, it will be minus x plus x square by 3x square. This x will cancel with this x, and this x square will get cancelled with this x square. It's 1 by 3. So p plus q is 4. So by either way you are getting 4. So based on like the method you are comfortable in, you can have it either L'Hopital or Taylor series. Okay, so not a difficult problem, but yeah, you will get a problem on limits, solving the limit. This is on continuity and differentiability. So again a piecewise function is given, and in case of piecewise function, the point at which we need to take utmost care is where the function is breaking. The point or the value of x at which the function is breaking should be taken into consideration. Apart from that, it's a continuous function. No matter what the value of a or b is, it is always polynomial, and all polynomial functions are differentiable, and if the function is differentiable, it is also continuous. So any value of x which is less than 1, it is differentiable and continuous. Any value of x which is greater than or equal to 1, it is 2x plus b, which is again a polynomial function, a linear function to be more precise. So it will be continuous and differentiable, but at 1 we need to check. Okay, so let's see one by one, because there is an option in which we need to comment about continuity and then for differentiability. Okay. First, let's see continuous, whether it is continuous or not. To check whether it is continuous at x is 1, we need to compare the left hand limit with the right hand limit. It should be equivalent. Let's check continuity. For continuity, left hand limit should be equal to right hand limit at x is equal to 1, right? Okay, so limit x tending towards 1 minus, when we are approaching 1 from the left hand side, a value which is very near to 1 but it is slightly less than 1, this will be the value of function. Value of function will be x square plus ax, which is, if you put x as 1, it will be 1 plus a times 1. It's 1 plus 8. This is left hand limit. Similarly, we can calculate right hand limit. When x is slightly greater than 1, f of x, it will be 2x plus 1. So 2 times 1 plus b, which is 2 plus b. So if we want this function to be continuous, left hand limit should be equal to right hand limit. This should be equal. In order to have continuity, left hand limit should be equal to right hand limit. If these limits are equal, then we can say it is continuous. This will give us a relationship between a and b. So a plus 1 should be equal to 2 plus b. It gives a minus b is equal to 1. Equation number 1. In order to hold continuity at x is equal to 1, a minus b should be equal to 1. That's it. Second, for differentiability, either you go with the limits way, or better if the function is differentiable, which is polynomial, you can anyway find the derivative of both the parts. The derivative would be 2x plus a when x is less than 1, and it is 2 when x is greater than or equal to 1. So left hand derivative should be equal to right hand derivative in order to hold differentiability for 1. For differentiability, left hand derivative should be equal to right hand derivative, right? So to find left hand derivative, we will differentiate the left hand side with respect to x and put 1. It will be 2 plus a. Right hand derivative would be 2. This equality should hold in order to have differentiability at x is equal to 1. And when this holds, this will give a as 0. Only for this case, when a is 0, this function will be differentiable at x is equal to 1. And when a is 0, what will be the value of b? B will be minus 1. Only for a comma b as 0 comma minus 1, this function is differentiable at x is equal to 1. That's it. Otherwise not. Let's see the options. The first is fx is continuous at x is equal to 1 if and only if a plus b is 1. A plus b is minus 1. The answer is no. A minus b should be 1, then only it will be continuous. Incorrect. Second option, fx is differentiable at x is equal to 1 if and only if a is 1. No, a should be 0. Incorrect. Third, if fx is differentiable at x is equal to minus 1, x is equal to 1, then it is continuous at x is equal to 1. It's a generic statement. If it is differentiable, then it will always be continuous. Differentiability implies continuity, but continuity does not imply differentiability. So this is true. If it is differentiable, then yes, definitely it will be continuous. Fourth option, there exist values of a and b for which fx is continuous at x is equal to 1 but not differentiable at x is equal to 1. This is interesting. Is there a combination exists such that the function becomes continuous but not differentiable for 1? The answer is yes. Whenever a is not equal to 0, the function is not differentiable. You take any value of a. Take a as 2. If a is 2, then left hand derivative is not equal to right hand derivative. Left hand derivative is not equal to right hand derivative. So non-differentiable. Left hand derivative at x is equal to 1 is not equal to right hand derivative, so non-differentiable. But if we put a as 2 in equation 1, we can get a value of b such that a minus b holds 1. This equality holds. So we can find a configuration. If a is 2, we can find a b. We can find a corresponding b such that b is equal to a minus 1. 2 minus 1, which is 1. For this configuration, a as 2, b as 1, this is continuous. Why this is continuous? Because left hand limit is equal to right hand limit. For this configuration, a as 2 and b is 1. Make sense? So you take any value where a is not equal to 0, you will get a configuration such that it is continuous at 1 but non-differentiable. Right? Clear? So option C and D are right answer for this problem. Any confusion in this? And this is also a good problem. Problem that deals that will clear your concept regarding how to find the function is continuous or not, how to find it differentiable or not, or whether it is. They can also ask. They can form an integer problem and ask you, given the range minus 10 to 10. For what values of a the function is non-differentiable? Count the values of a such that the function is non-differentiable. It will be 10 and 10, 21 minus 1. For 20 values it is non-differentiable in this range. They can any problem, good problem can be framed on this concept. A should be correct. Why A should be correct? For fx to be continuous, a plus b should be equal to minus 1, but a plus b is not minus 1, a minus b is 1. This is the equality which we are getting in order to hold continuity at x equal to 1. In order to hold continuity, the relationship between a and b is a minus b should be equal to 1. That's it. 1. Is it clear? You still have confusion in this A part? A is incorrect, A is not correct. No, differentiability is different. We have two conditions. First, for continuity, where the original function is used in order to derive the left hand limit and right hand limit. And then we have differentiability, where we differentiate, since it's a polynomial function, we can differentiate and then find the left hand derivative and right hand derivative, put x as 1 and get the values. Alright. Next problem. Find the minimum value of the function. It's easy. So a function is given, you just have to find its minimum value. So f of x is given as x plus 4 by x. We will differentiate. First derivative would be 1 minus 4 by x square. We will find critical points, equate it to 0. It's 4. It will give x square as 4. So x as plus minus 2. X as plus minus 2. And in order to ensure that which critical point will lead to minima or maxima, we have to find the second derivative, f double dash x, which is minus plus 8 by x cube. So we want to find minimum value. So there should be a value, there should be a critical point such that if you put it in double derivative, if in f double dash x, it should give you positive number. So f when x is equal to 2, f double dash 2 is positive, is 8 by 8, which is 1 greater than 0. When x is equal to minus 2, f double dash x or f double dash minus 2, it's 8 by minus 8, minus 1 less than 0. In order to get the minimum value, this should be the scenario. This will give you minimum. For x as 2, we need to find, give your answer as integer, find the minimum value of the function. We have to find f of 2. Minimum f of 2 would be 2 plus 4 by 2, which is 4. 4 is the minimum value of this function. Right? It's easy. Next, another function is defined as x to the power 4. This is also an interesting problem. So there can be a very good problem on whether the function is concave up, whether the function is concave down, whether the differentiation or the slope is positive, slope is negative, and so on. So function is given, and you need to find the correct statement. It's multiple select question. Option A is fx is concave up in this interval. Second is it is concave down in this interval. Third is it is strictly increasing, first derivative, and fourth is double derivative is increasing. So how to identify these things? How to identify these things? So concativity up and concativity down, the funda is very simple. In order to check whether the concativity of the function is towards up or towards down, we need to identify its double derivative. It is directly linked with the sign of double derivative. Okay, let's see. First derivative f dash x. First, let's calculate the critical points of this function first. First derivative will give us 4 times x to the power 3 minus 8x minus 8x. Right? What are the critical points? The critical points would be, one is 0, it will be 0, then 4x square minus 8 is 0, 2x square is 2, plus minus root 2. These are the critical points. Right? Then second derivative f double dash x, which if we can take 4 as common, x cube 3x square minus 2. This is second derivative. Now concativity directly depends upon the sign of this second derivative. The straight rule is if my f double dash x is positive, if double dash x, second derivative of function, is positive for all values of x, it will be concave up. It will be always concave up. This will be the slope. Concativity will be upside. Second, if f double dash x is negative, in that case it will be concave down. So you have to remember this in order to deal with the functions which are not intuitive when it comes to graphical representation. It is difficult to plot the graph of these functions or like functions like these. But like since we have critical points, so the derivative is getting 0 for this. So it will be a symmetric function. It will be a symmetric function. It will be a symmetric function where derivative is 0 at this point, minus root 2 and plus root 2. Derivative is 0 at these 3 points. But yeah, we don't care. Like we are not here to plot the curve. We just want to know the interval for which it is concave up or concave down, the concativity of the original function. Alright. So in order to check the interval for which it is concave up, we have to see the values of x such that double derivative is positive. So double derivative is 3x square minus 2. So 3x square minus 2 should be greater than 0. Then it is concave up for all values of x, which is satisfying this inequality, right? Which is 3x square should be greater than 2, x square should be greater than 2 by 3, x square should be greater than 2 by 3. So what are the values of x? Minus infinite to minus square root of 2 by 3, union 2 by 3 square root till infinity. In this interval, fx will be the concativity of the function, concativity of the original function will be towards up, right? And all the interval which is not r minus this interval is concativity down. This is concave up, and we are discussing the concativity of the original function f of x. So this is the interval, and for concativity downwards, r minus this, which is from minus 2 by square root 3 till 2 by 3 square root. In this interval, it will be concave down. The function will be concave down in this range, right? Okay, so let's see. Option 1, fx is concave up on minus infinite to minus 2 union 2 to infinity. No, it is from minus infinite to minus square root of 2 by 3. Square root of 2 by 3. It is excluding the values. It is excluding the values from 2 by root 3 to 2. Since 2 by root 3, square root of 2 by root 3 is less than 2, so it is excluding the values present in this range. So this is incorrect. This is incomplete range. This is incorrect. Okay. Second, fx is concave down on minus 1 to 1. Again no. Again no, it is not. It is concave down from minus 2 by root 3 to 2 by square root of minus 2 by root 3 to square root of 2 by root 3 when mod of x is less than 2 by root 3. When mod of x is less than square root of 2 by 3. Make sense? Okay, then next, f dash x is strictly increasing on this interval. So what is the criteria of strictly increasing? How will you identify that function is strictly increasing or strictly decreasing in an interval? What is the criteria for that? What is the criteria for that? The criteria is same, this. If we are talking about concativity of f of x, if we talk about concativity, if it is concave up, then f double dash x, and this is, oops, yeah, listen it very carefully. For the original function, If I need to comment about the concativity of this original function in a specific range, then its second derivative f double dash x should be greater than 0. Its second derivative should be greater than 0. Now third point says first derivative is strictly increasing in this range. If a function, we need to identify whether a function is strictly increasing or not. This is first derivative, this is the function. I need to comment about whether it is strictly increasing in this range or not. For a function to ensure that it is strictly increasing, its first derivative should be positive in that range. And the first derivative of f dash x is f double dash x. So f double dash x should be positive. F double dash x should be greater than 0 to ensure that f dash x is increasing. Yes or no? Treat this f dash x as an independent function. I want to forget the original fx. This is an arbitrary function. If it is given as 4x cube minus 8x and I want to know whether it is increasing or not in a specific range, I just need to check its first derivative. Its first derivative is f double dash x. So if f double dash x is positive in that range, in that case I can say that the original function is increasing. The original function is increasing. Make sense? Intuitively I can explain you this in this way as well. If this is the curve, what is the slope? Slope is the tangent of the theta that is made between the x-axis and this line theta. This as theta is increasing, the slope is increasing. And how to identify? We just need to calculate if f dash x is greater than 0 or not. If the first derivative is positive, in that case the function is increasing. So this is the same. We are talking about its first derivative. If you treat it as an independent function and you need to identify whether f dash x is strictly increasing or not, just check its first derivative is positive or not in this range. And we have already calculated that this is the range in which it is positive while discussing about concativity. So yes, it is correct. F dash x is strictly increasing in this range. C is right. Any confusion in this? You just have to take the first derivative of this function, which is f dash x. The first derivative of f dash x is f double dash x, the second derivative of the original function. That's it. Okay. Then the last, f double dash x is increasing on 0 to infinity. F double dash x is increasing in 0 to infinity. Again same. The same criteria. Treat f double dash x as an independent function, as g of x. Treat this as g of x, whose value is equal to 4 times 3x square minus 2. 4 times 3x square minus 2. Now read this question. I have a function g of x. I need to check whether it is increasing or not. I will just take its first derivative and then identify. I will just take its first derivative, which is the third derivative of the original function. I will take g dash x, which is 4 times 6x, and check whether it is positive in this interval. Answer is yes, it is. If you put any number greater than 0, it is always positive. It is always positive in this range. So D is also right answer. D is also right answer. Clear? Understood how to deal with these problems? Any confusion in this? And this is the basic rule. How to check whether a function is increasing? Check its first derivative. If it is positive in that range, then the function is increasing. The slope is positive. If the slope is positive, then the function will anyway increase. It's a positive slope. Alright. Next, this is easy problem, and this is from optimization, single variable optimization. We only have after maxima minima, the application of maxima minima is applying it to optimization, and in our syllabus we only have single variable optimization. We do not have dual variable optimization or more than 2 variables. So if you see a question, there will always a way in which you can eliminate all the remaining variables to get a equation in single variable, then you can apply maximum minimum on that. And this is a basic illustration on that. A farmer has 120 meters of fencing to build a rectangular pen along a straight river. Okay. So fencing length is 120 meter. The river forms one side of the rectangle, so the farmer needs fencing for only 3 sides, 2 widths and 1 length. Okay. What is the maximum possible area of the fencing? What is the maximum possible area of the fencing? Some information is given, which is he only needs to fence on 3 sides, not all 4 of them. So 2 times width plus L. 2 times width plus L, what it will be? It will be the total length of fencing, which is given to us 120. This is already given to us. The length of fencing is given, and we need to find what can be the possible area if a 120 meter length fencing is used to cover a region from 3 sides. That's it. What will be the area? Area will be L times W, equation 2. Now we have 2 equations and 3 variables. Area we need to maximize. So can we eliminate, like area is in 2 variables L and W. Can we eliminate one variable using the additional information? In this, it's straight away parameter is given, but if the problem is asked, they can frame it in any manner such that final equation, the maxima function or minima function that you want to optimize, should be in a single variable. That's it. In this case, you can like replace anyone, it's like fine. So you can put L as 120 minus 2W times W, and then optimize it. Find its first derivative, find its second derivative. In order to have maxima, the second derivative should be negative, and we can see that it will be negative. So it's 120 W minus 2W square. This is area in terms of width. Area in terms of width. This is our optimization function, and we need to maximize it. We need to find max area. Okay, and yeah, it's like now it's easy. dA by dW, which is equal to 120 minus 4W equal to 0. It will give us a critical point. W is 30. If W is 30, d2A by dW square is minus 4, which is negative, so it will be a maxima. It will be a maxima at this critical point when W is 30. If W is 30, we can put it in equation 1 to find L. What will be the value of L? 30 times 2, which is 60 minus 120. L would be 60. And if W and L are given, you can put it in area and get the maximum area. A max would be this times this, 1800. 1800. I think it was MCQ and I missed putting options over here. 1800 meter square is the right answer. Okay. All right. Okay, any confusion in calculus? We are done with the calculus problems, and the last 9 problems are remaining from AI. Any confusion in it? Let's take a short break. Then we'll discuss the last 9 problems from AI. Okay? Okay, so let's continue with AI, and we have 9 problems, 5 1 mark and 4 2 marks. AI is also like, till now whatever questions that we have got in the last 2 years from AI are not very difficult, but given a year they can like frame very good problems from AI from uncertainty. Logic part is easy, and search is also not that difficult. We have only straightforward problems either on heuristics or like a uniform cost or on minimax algorithms, alpha beta pruning. We have only a set of algorithms which they are asking problems on, but given day they can like frame a very good set of problems from these, like either these algorithms or the uncertainty topic that is not yet exploited by the authority yet. Okay, so let's see. The problems are not that difficult. I haven't given difficult problems from AI. First is consider state space search problem. Following properties: branching is finite, state space may contain cycles, so it's cyclic. Step costs are positive but not necessarily equal. Okay, unequal step costs are there but not negative. The question is, which one of the following statement is correct? It's single correct problem. So BFS is guaranteed to be optimal under these conditions. Can we comment about optimality of BFS if the step cost is not uniform? Can we comment about the guarantee that BFS will be optimal if the step cost is not equal, unequal step cost? The answer is no, we can't. We can't. Option 1 is incorrect. BFS only works for equal step cost. Every step is considered equivalent and it will do level ordering traversal. It will go to all the nodes. It will, what we can say, it will unfold all the nodes in this manner. Yeah, it won't matter whether the cost is unequal or not, it will treat as equal. So it will first unfold this, all nodes at level 1, then all nodes at level 2 and so on. It will do the traversal like this. BFS, the first is incorrect. The optimality is not guaranteed when the step cost is unequal. Make sense? Okay, second is uniform cost search, UCS is complete and optimal under these conditions. Yes, it is. What is the cost function for UCS? For UCS, the cost function F, the cost function is equal to the step cost, and no matter what the step cost is, as long as it is positive, it will give us the optimal result, because it is internally using priority queue, which is designed in such a way that the cost having lesser priority would be unfold first or traversed first, right? So second is correct. Third, uniform cost search is it's same. Uniform cost is complete but not optimal under this condition. No, it's incorrect. It will be optimal. It's additional not over here. It will be optimal. B is correct, C is incorrect. Finally, iterative deepening depth first search is not optimal when step cost are unequal. Any comment about iterative deepening DFS? Iterative deepening DFS. This is also incorrect. This is not correct. When step cost is unequal, then these algorithms, any tweaked algorithm regarding DFS and BFS won't work optimally when it comes to unequal step cost. Just take this in mind. Only the uniform cost, since it depends upon the cost of the path that we need to take next based on all available options that we have currently, it will only be the optimal scenario, right? Okay. So you have to like understand these algorithms, and you can expect a word problem on definitions regarding variations of these search algorithms. Next, this is on heuristics. A set of heuristics is provided for all the nodes. A greedy best first search is run from S to G. This is our initial state and this is the goal state where we need to reach, where the search always expands the frontier node with smallest heuristic value ignoring the path cost. Now this is not A star. This algorithm is not A star. This is only using heuristic and not the path. G of n is not used. So all these 1, 4, 2 are irrelevant. They are not participating in getting to goal state starting from S. This is not A star. In A star, the cost function f of n is g of n plus the heuristic, right? In UCS, the cost function is only g of n, no heuristic is involved. But in this case, it is only using heuristic. So it is neither A star nor UCS. This algorithm, the cost function f of n is only the heuristic value of that node, just the heuristic value, independent of the path cost or the sum of path cost and the heuristic. So it only relies on the estimated distance which might be left till the goal state is reached. This is what the heuristic is, the estimated length of the goal state from the current node. Alright, so given the directed graph with path shown, which path will be selected by the greedy best first? This is greedy best first. This algorithm is known as greedy best first. So idea remains the same, it's just a difference in the cost function that we will be using in order to form the priority queue. We are at S, so it will be, priority queue will be like this. We are at S, and after unfolding S, what will be the values that will be putting, what are the nodes that will be putting in the priority queue? If I am at S, what next node can I explore? Will be the nodes that we gonna be putting in this priority queue. This is priority queue. Every time in this search, in these sort of search algorithms, you will be using priority queue. It can be UCS, it can be A star, or it can be this algorithm which is greedy best first. A priority queue is always be used, and the priority is defined by this cost function. In this case, it only depends upon the heuristic. What is the value? If this is the case, what should be the value? Anyone? Tell me in the chat. There's a question, UCS cycle में नहीं फंस सकता. We also maintain a visited list. Along with UCS. In UCS, we also maintain a visited list, जो कि बचाता है उसे साइकिल में फंसने से. You mark the nodes which are already traversed so that it do not go to these nodes which are already explored or expanded. Make sense? Yeah, if this is the scenario, what are the nodes and their cost function that we're going to be putting in this priority queue next? There can be two possibilities. Either you can expand A or you can expand B. Which will you choose? Which will you choose, from A or B? Anyone? The choice is purely based on heuristics. The heuristic of A is 4. This is how we used to calculate the path. We will calculate the cost function of f of A. The cost to reach A from S. Look, the cost to reach A from S, this cost. This would be h of A. And what is the value of h of A? H of A is 4. The cost is 4. So we will put an element in the priority queue with value as 4. Node A, cost as 4, we will put in the queue. Next, there is one more possibility, this. S to B. What is the heuristics? It is 2. F of B is h of B, which is 2. So B, 2 will also be, we will put in priority queue. Then based on the priority, Based on the priority, we will remove, or we will remove the element from this queue having least priority. In this case, we have two paths. Either from S we can go to A, or from S we can go to B. But if we take this path from S to B, this is having lesser cost. This is why it's greedy based algorithm. It is working on a greedy manner. Give me a path which is having the least cost from S based on just the heuristics value, which is B. So the next would be, if I am at S, I will remove B, 2 from my priority queue, and then expand the nodes or the paths from B. From B, we have one path B to C. Heuristic is 1. So f of C would be h of C is 1. So we will add one more element in the priority queue, C, 1. And S, B we have already expanded. S to B we have already explored. Now we have two choices. Either we can expand A or we can expand C. Either we can expand, they both are ready to be expanded. Based on the cost, we will always expand the minimal cost. So 4 and 1, if we have to choose, we will choose C to expand. It will get removed. From B, we will go to C. From B, we will go to C. Now, if we are at C, this is the path that we are taking. From B, we are going to C. From C, there is only one path towards G, which is having cost as 0. F of G having H of G as 0. So G, 0 will also get added in this priority queue. Now again we have two options. Either you can expand A or you can expand G, but we will always choose the least cost, because this is what the advantage of having a priority queue is. The next will be node that we will be expanding is G, which is the goal state. And as soon as the goal state is reached, the search stops. This is common for UCS, this is common for greedy first, this is common for A star. As soon as you get the first node which is present in the priority queue and is a goal state, the search will stop. Right? Okay, so S to B, C and G and A will remain unexplored. A will not explode. So we can, like, a problem can be framed, what are the nodes which are not even expanded. There can be a node from A, say F or G. There can be few other nodes, not G is already taken. E. All these nodes A, F, E are not expanded. This S, B, C, G will be the path of this greedy based algorithm based on just the heuristics. But the path might change if you include the factor of the cost. If you include the factor of the cost, you can tweak the cost function such that F is equal to G plus H or some variation of this. You can have a linear combination. You can have a weighted A star, associate some weight with this heuristic in order to compute the cost function. You can tweak these algorithms and have different variations of the similar algorithm, but the underlying logic is the same. You will maintain a priority queue, and each expansion will lead to addition of elements in this priority queue, and the expansion of the new nodes will only be based on the least cost of the total elements which are present unexplored in this queue. That's it. Okay, so S, B, C and G. This is the right answer. Option B. Clear? Any confusion? And again, you will get a problem on heuristic. You will definitely get a problem on it. Consider the following game tree evaluated using minimax algorithm. What is the minimax value of the root node? This is easy. This is just the standard minimax. No variation, just standard minimax. You apply max to this layer. Out of this, this will be the chosen one. Max becomes 5. You apply max in this, 9 will be the value of max node. Now here 12 will be the value of max node, and here you can take any 23, it's same. Now out of these max nodes, min will be chosen, 5 and 9. 5 will transmitted, min becomes 5. 12 and 23, this becomes the value of this min node, and out of these two mins we have to choose the maximum, so it will be 12. This is the max value or the minimax value of the root node C. Right? It's a state problem directly asked from standard minimax, and there are variations in minimax as well. I was like reading about this minimax algorithm. I don't know whether it is in the scope of gate or not. Like I think it's not, but there is one more variation in minimax, not alpha beta. In between alpha beta and minimax, it's expecti minimax. We associate some sort of expectation from the nodes rather than just by picking minimum or maximum value. We associate some probability of choosing the value. So you can read about it. Okay, the next is also a problem on searches only. Assumption is positive step cost, finite branching, and admissible heuristic. This is important. You can get a problem on just on the admissibility of heuristics. We got a problem from last year. Admissibility of heuristics. Given two heuristics based on their linear combination, performing some arithmetic operations on different admissible heuristics, it was asked whether the resulting heuristic is admissible or not. Okay. So select or correct statement. First is BFS is optimal when all step costs are equal. Yes, it is. We have seen the similar problem. It is easy only. Yes, it is correct. Step cost is same. BFS will always give you DFS will always give you optimal cost to the goal state. UCS and A star always expand nodes in the same order. Is it correct? No, it is not. UCS is different algorithm. A star is different. UCS uses cost function as G, only G. A star is using the cost function as G plus H. There is a factor of H in identifying which node should I expand because this cost is changing. So B is incorrect. Third, DFS may fail to find optimal solution even if all step costs are equal. There might be, yes, this is true. What can be the scenario if this is the case? Because this is how DFS works. This is node A, B, C, D and E. Now you have F and you have G, and in the goal state you have two nodes, E and G both, but you have designed the algorithm such that it always expands the left hand side of the current node. If the algorithm is designed such that it is going towards this direction first, then it will expand this, then D, then E, and then it will halt at this. It will return that goal is reached. This is goal. Even though there was another goal state having a lesser depth or optimal only 2 steps away from the starting state, but it will return. It will halt the algorithm and it will return that goal state is reached with this cost 1, 2, 3, 4. With cost as 4, even though a goal state was present with cost 2. So C is right. Okay. Then A star is guaranteed to be optimal under the given assumptions, and the given assumption is it is admissible. If the heuristic is admissible, then A star is always optimal. This is what the definition of admissible heuristic is. It won't overestimate any of the paths which are remaining. It won't overestimate anything. It won't overestimate a path from node A to node B. It will always underestimate. If it is underestimating, then A star will always be able to get the optimal cost. Right? Okay. Next, identify the correct translation into first order logic of the following assertion. So this might seem complicated, but if you read the statement and then you start reading these 4 options, you will straight away get the answer. It says every student in the class likes at least one subject taught by the class teacher. Every student in the class likes at least one subject taught by the class teacher. And these are some predicates that are used in these equations. Student X is a student, subject Y is a subject, teaches T and Y, teacher T teaches subject Y, likes X comma Y, X likes Y, and some constants which are, I don't think it's used somewhere. For teachers it's used, constantly denotes the class teacher. Okay, out of which we have few other predicates as well which are irrelevant with this statement. So you can eliminate these options straight away. We have this recognizes. This recognizes is nowhere present in the initial statement. So D is straight away rejected. D is straight away rejected. And if you read option A, it says for every student we have student X implies there exists a C. In the class, at least one student, there exists a C, which is there exists a Y which is a subject, and T teaches this subject Y, and X lies this Y. This is exactly the statement which is present. This is exactly the statement which is present. A is right. B is there exists a Y. There exists a subject. Itself long. It is starting with there exists a subject. C is for all X there exists a Y. But this doesn't include teaches. C doesn't includes taught by the teacher, taught by the class teacher. The teacher's predicate is missing. Therefore, C is also not the right answer. So A is correct. Okay. Second is consider the following well-formed formulas in propositional logic. So 3 formulas are given: F1, F2 and F3. Select all correct statements. We need to comment about unsatisfiability, validity, satisfiability of these formulas. For that, we should know what the meaning of these terms are. What is satisfiability? F3 satisfiable. What is the meaning of this statement? F3 as a specific propositional logic is satisfiable. What is the meaning of this? What is the meaning of satisfiable? Anyone? What is satisfiability? And also tell me what is validity. A proposition is valid. Then there is one more term, unsatisfiable. What is this unsatisfiable is? If you do not know these things, you won't be able to solve, you won't be able to mark it correctly. Satisfiability means for all possible combinations of P, Q, R, that's it. Only three. For all possible values of P, Q, R, or there should exist at least one configuration of PQR which is making the overall proposition as true. It should be true for at least one case. It should be true for at least one case. And what is the meaning of this one case? A specific configuration of PQR, or the atomic predicates which are associated to form the proposition, right? Then validity is equivalent to tautology, which is it should always true for all combinations. It should always be true. Always be true for all possible combinations. So if I am talking about validity of F2, no matter what you put P, Q, It should always give you true. If it is giving true for all combinations, then it is a valid propositional logic, or you can also like validity is equal to tautology. Then third, unsatisfiability. Unsatisfiability is contradiction. If it is not satisfiable, if it is not satisfying the criteria that it should be true for at least one scenario, then it is false for all. Then it is unsatisfiable. So it should be false for all. Should be false for all. And also called as contradiction. Also called as contradiction. That's it. If you know this, you can easily figure it out. What is satisfiable, which is contradiction, and which is a tautology. This, for instance, the second one is it's P implies Q. If P implies Q, you can simplify this. A implies B can be written as negation of A or B, right? It can be written as negation of P or Q, union Q implies P, which is negation of Q or P. And if you see it closely, it is always a tautology. No matter what you choose the configuration from P and Q, it will always be a tautology. It is or in between. It is or in between. Because it is having all possible 4 combinations of P and Q, negation of P, Q, negation of Q, and P. You can take any value of P and Q, it will always be a tautology. So F2 is valid. B is right. F2 is valid. And again, you will find a configuration such that F1 is true at least for one scenario. It is not valid. F1 is not valid, but it's satisfiable. It is satisfiable. The hard way is to take combinations of PQR, and this is also the recommended way. If you have time in the exam, always go for the truth table. Always go for the truth table. It will, like, at least you won't lose marks. You will have certainty if you are identifying all possible combinations, all 8 combinations of this. You will straight away conclude that whether it is validity or whether it is valid or satisfiable. So always go for truth table, and that's it. PQR only 3. 3 is doable. 4 becomes a bit hectic. 4 or 5. So the correct answers for this, it will be it will be unsatisfiable. It will be false for all, not satisfiable. It will be unsatisfiable. And F3 is satisfiable but not valid. It is false for at least one configuration. I think for a configuration P and Q are true, P true, Q true, R false. So this is overall F3 becomes false. If we found at least one configuration when the propositional is false, then it is not valid. It is not valid, and D is wrong. A, B, C are right answer for this. Okay? It's easy, only propositional, basic propositional logic. Next is Bayesian network. D separation. This is also interesting. Not that difficult, but you have to be attentive for this problem. It's not that straightforward. So always form a DAG in this case. You have X, then you have Y. You can form Z, X to Z, Y to Z is connected. Then you have a link from X to W and W to Y. X to W and W to Y. And D separation is not that difficult. We have discussed thoroughly D separation in class. In order to find whether two sets are conditionally dependent or independent, D separation algorithm is used. If they are separated, if they are de-separated, then they are conditionally independent. If they are not de-separable, they are conditionally dependent. And we have a algorithm for that. For instance, if you are checking for A part, x, whether x is conditionally independent of y or not. In this case, the third set is phi. Third set is not given. No conditional thing is given. We just need to check whether x is conditionally independent of y or not. The first step for A part, the first step is to, what should be the first step? Draw an ancestral graph. Take all nodes present in this set x, y and form ancestral graph. Ancestral graph will look like, it will have x, it will have y, and all the nodes which have a link either to x or y, all parents, grandparents, grandparents of x and y. In this case, only w would be part of the ancestral graph. Z is child of x and y, so it won't be part of this. Yeah, this will be the ancestral tree. This will be the ancestral tree. Second part is to moralize, to have a node, to connect the parents. In this case, no parents will be connected. The second part is to, what should be the second part in this case? Anyone? What should be the case? After having ancestral graph, second step is to moralize, to connect the parents. To connect the parents. In this case, no, we won't be making any connections. Yeah, second step is to moralize. Since there are no common parents of any of the nodes, so no additional nodes, no additional edges will be created after this step. The graph remains same, x, y and w. There is a edge from x to w and then w to y. Third step is to get rid of the directions in the edges. Third step is to get rid of directions. It will be x, then w and then y, like this. And fourth step is to get rid of this condition. In option A, the condition is phi, so no nodes will be removed. And then we need to check whether there is a path exist from x to y. Is there a path exist from x to y? In this case, is there a path exist from x to y? Yes or no? Is there a path exist after having we started with the ancestral graph, then moralized the edges, then get rid of directions and removed the conditions, all the nodes present in conditions. Is there a path exist? Answer is yes, it exists. Via w, there is a path like this. So they are not de-separated. And A option incorrect. They are not de-separated. Right? Similarly, we can check other options as well. Let me quickly do for one more. X, Y, Z. In this case, Z is also included. It will be like this. So we have X, we start with X, Y and Z. Ancestral graph, how will the ancestral graph look like? X, Y and Z. Since W is parent of Y, so W will also be in the part. So it will be W, complete graph, X, Y, Z, like this. This is step 1, ancestral graph. Step number 2, what will be step number 2? Step number 2 is moralize. Since there is common parent, Z has a common parent X and Y, we will add a node. It will be X, Y, W, Z. There will be a connection between X and Y. Why? Because X and Y are parents of a node present in the ancestral graph. That's why. Third step is to get rid of condition. Third step is to get rid of this Z. Remove this Z. If we remove the Z, all the nodes associated with Z will also be removed. It becomes X, Y, connection and a node W, x to W, W to Y. And fourth step is to get rid of the edges. It will give us W, X and Y all are connected. Is there a path exists from X to Y? There is a direct path. The path exists, so not D-separated. Not D-separated. B is also incorrect. Not D-separated. Similarly, third, X, Y and W. Start with X, Y and W. So once you practice, it becomes easier. You take X, Y and W. Z won't get included because Z is children of X and Y. In ancestral graph, you only take nodes that can be reachable to any of the nodes X, W or Y. From Z, you can't reach to X, you can't reach to Y, or you can't reach to W. So Z won't be a part of the ancestral graph. So it will be X, W and Y. That's it. That's it. For I'm talking about C, part C. This is part B. This is option A. Okay. This is first step. Second step is to moralize. No parents, so no new nodes. It will be the same. Third is to get rid of the condition. Get rid of W. Third is get rid of W. If you get rid of W, you will have to remove these edges. If you have to remove these edges, then X and Y becomes separated. In this case, they become separated. There is no path from X to Y after W is removed. After the condition is removed, you can't reach to Y from X or vice versa. Therefore, they are D-separated. They are D-separated. Make sense? C is right. And similarly, we can prove that D is not D-separated. X, Y, W, Z. Let's see. For D part, it's X, Y, Z, W. We are adding all the nodes. Ancestral graph will be the complete graph W, X, Y, Z. Like this, like this. Second part is to moralize. Since Z has parent X and Y, there will be a connection. X, Y, W, Z. It will be like this. And there will be a connection like this. And after having the connection, next step is to get rid of the conditional nodes W and Z. Get rid of W and Z. If you remove Z, if you remove W, we only left X and Y. But since X and Y are parents of W, there is already a connection. There is already a connection between X and Y. Even after we remove these conditions, you can go from X to Y. Therefore, they are not conditionally, they are not D-separated. They are not D-separated. If they are not D-separated, so D is not the right answer. So only option which is D-separated, which is C, X is conditionally independent of Y given W. This is how it is read. Two sets, and you can have multiple nodes in these sets as well. D-separation is a generic algorithm. You can have the capital X is a set which is D-separated to another set of nodes Y given the condition that all W's are also given. Like standard wise it is Z. This is a set of nodes. This is also a set of nodes, and this is also a set of nodes. This set is conditionally independent to this set given this set. And this is the algorithm how you identify the D-separation or conditional dependence or independence. If it is D-separated, they are conditionally independent, or if they are not D-separated, then it's dependent. Right? There is a fly which is disturbing. Okay. Next, any confusion in D-separation? D-separation is clear, and you can get a question on D-separation. It is not that difficult, but it's like once you know like to solve, you can easily solve it. D-separation algorithm it's a standard algorithm. The algorithm has 4 or 5 steps. Starting with, the algorithm starts with, there are 3 parts in the conditional equation that is given to you. A set X, a set Y and a set Z. You take all nodes present in X, all nodes present in Y, all nodes present in Z and form a set. All the nodes present in X or Y or Z, you put it in this. This is your starting point. This is the set of all the nodes present in this. Once you have all the nodes, the next step is to form the ancestral graph. Ancestral graph is a graph which is having all the nodes that are reachable to the nodes present in this set. All the parents, their grandparents, grandparents, and once you have the ancestral graph, the next step is to identify the common parents of the nodes. Basically, like intuitively, if I have to explain you, we need to find a way such that a node from this set, there should exist a link from set X to set Y even if W is removed. The overall algorithm revolves around this intuition. That's it. Okay. All right. Next, consider the Bayesian network. Okay, and there is one not prerequisite. You have to take an assumption from your side in this problem that all these nodes are binary. If nothing is given, always go with binary. All these nodes are binary. Only two values, true, false, for all these nodes. Otherwise, you won't be able to solve it. Okay, so consider the Bayesian network like this. It's given A to B, there's a link, A to C is also a link, and B to D and C to D is also a link. How many independent parameters are required to specify the full joint distribution using the Bayesian network factorization conditional probability tables? And this is not that difficult, it's easy only. So we have the formula for that. We can also derive that formula, which is for node X, for node Xi, for a specific node X, it can be A, it can be B, C, D, it can be anything. If this is the node, there can be connections like this, an independent node where there is no incoming edges. There can be a connection like this, where there is only one incoming edge at B, or there can be a connection like this, A, B, there can be two incoming edges, or so on, or so on. But you can have a standalone node or a node from where you are starting your Bayesian network. In this case, this A, there are no incoming edges to A. Second, there can be a node B which can have only one incoming edge from A to B. For example, C, B are of this type. Third is, there are two incoming edges or more than one incoming edges, which is D. In this case, we have two edges. So this is a general, like for a specific node X, the total number of parameters are equal to R minus 1, Ri minus 1 times Q of I. Ri minus 1 times Q of I, where Ri, this is the number of states of Xi, and Q is the number of parent configuration or the number of incoming edges. It's the same thing. Number of parents. So in this case, if we are going with an assumption that all of these nodes are binary only, so Ri becomes 2 for all of them. So the only dependence on the number of parameter is on Q of I. Depends upon Q of I. Right? Number of, not exactly parents or incoming edges, number of parent configurations. Total configurations required for the parents. Number of parent configurations. Okay. So we'll calculate for each of them. For node A, what it will be? How many parent configurations are required for node A? Only one, right? Only one. 0 parents. It's 0 parents, and Q are also this Q can also be written as 2 to the power number of parents of I. 2 to the power number of parents. In this case, A would be only one configuration is required, which is since it's a binary variable, if I can give you the probability of 2, like P of A, if I give you P of A, say 0.3, this is one parameter that I am giving to you. You can identify P of negation of A as 1 minus 0.3. Yes, so only one parameter is required in order to deal with this A. The node which do not have any incoming edges, only one parameter is required. That's why only one parameter is there. This can only be, it can be written as 2 minus 1, where 2 is the number of states of xi. It's a binary like a variable, so only 2 states, times 2 to the power number of parents, which is 0. So we can have a generalized formula to get the total number of parameters required for these variables, and this is it. Okay. Second, node B. For B, there is only one dependency on B, which is A. Based on the value of A, the value of B will be determined. So we can use directly this, and you can check, you can validate it using the Bayesian network. You can form the CPT and calculate the total number of parameters required to identify the probability of B given A. Okay, in this it will be 2 minus 1 since it's binary, and 2 to the power total number of parents, which is 1. For B, it's 2 parameters. For B, it's 2 parameters. For B, it's 2 parameters. Similarly for C, similar case, 2 minus 1 times 2 to the power 1, which is 2. And for D, it will be 2 minus 1 times 2 to the power 2, which is 4. Have an aggregation 9. You will need 9 parameters, assuming that all are binary. So if it is not given, then your binary is the best assumption to go with. Right? Okay. Last problem for the day, and we have seen similar sort of problem in class. The only difference was here it is undirected chain structure. If a Markov random variable, a Markov chain is given to you like this: P1, P2, P3, P4, so on, Pn. Then we have derived, like we have seen that if I am talking about probability, a conditional probability of any specific node P of I, any conditional probability of P of I, this will only depend upon the Markov blanket of the current node of which I am talking about. P of xi given x1, x2 till x minus 1, I minus 1, xi plus 1 till xn. This is equal to taking the probability x of I and only considering the Markov blanket of xi, the Markov blanket of ith node. In this case, the Markov blanket consists of the set of nodes which are the parent, which are the immediate parent of the specific node. In this case, it will be pi minus 1, xi minus 1. In this case, it will be x minus 1. So nothing is changed over here. The only thing that I have added is undirected chain. So rather than having this sort of chain, we have this chain: x1, x2, x3, x4, x5, x6. That's it. So in order to deal with the probability of a given specific node, this x3 will depend on both edges, this and this, x2 and x4. These two edges will contribute in order to get the conditional probability of x3, because the Markov blanket is updated. x3, the conditional probability is depending just on the Markov blanket, and since the edges are undirected, x2 and x4 both will be included, not just the preceding node or the preceding edge. That's the only difference. The question says you run single side gives sampling, in one full sweep we update all of them once. For gift sampling in Markov random field, the full conditional for xi depends only on its Markov blanket, and I have also mentioned it in the problem statement as well. It is xi is only dependent upon the Markov blanket. If you read this undirected edge and try to figure it out the Markov blanket of any ith node, it will be I minus 1 and I plus 1 if it is not x1 or x6. So for x1 it is only this x2 which is 1. For x2 it is x1 and x3 both, x1 comma x3 which is 2. For x2 again x1 x3. For x3 it's x2 and x4 which is 2. For x4 it becomes I am calculating the total Markov blanket, total nodes or edges present in the Markov blanket of these nodes. All intermediate nodes will having 2 apart from the first and the last one which is only having 1, since only one edge is there. x6 is only connected with x5 and x1 is only connected with x2. So 2 for this, 2 for this, 2 for this, 2 for this. 8 plus 1 plus 1 total 10. For x4 it will be 2, x5 again it will be 2 and x6 it will be 1. Sum it up, count would be 10. That's it. Right? And it was like integer type, 2 marks. And like I have mentioned that it only depends upon Markov blanket, its neighbors. Assume evaluating a full conditional requires accessing the pairwise potential on edges on intent to that node. Make sense? So across full sweep, how many edge potentials are accessed in total counting? Like total edge potentials are accessed in order to find the conditional, in order to find for this specific node only one edge is accessed. For x2 two edges are accessed. For x3 again two edges are accessed. And in between, like I have also mentioned that counting multiplicity, that is if the same edge potential is used in two different nodes, update the count twice. That's why this edge is contributing in this and this as well. This edge is contributing in this and this as well, and so on. Right? Any confusion? We have seen it in class, it is just an extension, just edges are removed, that's it. So yeah, this was the last problem in the test. Hope you guys enjoyed the test. And one more important announcement, that we have released the result. We have released your responses and the solution of all these problems that we have discussed in this live today in the portal. Just log in and analyze, verify your mistakes and start working on them. Right? Okay, anything else? Any doubt, any confusion? And your team will reach out to the rankers, so like you will get the access, don't worry, for test series as well as the course, so that yeah, you can rectify your mistakes and learn from them to get better in the exam. If you have directed edges, in that case yeah, Markov blanket will shrink. The x3 will only depends upon x2. x1 will be independent. So one for this, one for this, one for this, and one for this. Total answer would be 4, not 10 in that case, if the edges are directed. Make sense? Because you have changed the Markov blanket of each. Now this is what the regular Markov chain looks like. Every node is only depends upon just the node preceding that node. Question 6, which is that Yeah, the answer given to me is like this is unsatisfiable, this is valid, and this is satisfiable but not valid. So A, B, C. I haven't validated based on all possible combinations. You can verify, it's not a very difficult problem. What else? X6 depends upon X5. Yes. Right. Yeah. Correct. Nice catch. Thanks. Only X1 will be independent, rest all will depend on the previous nodes. Correct. Makes sense. Okay then, and like hope you guys enjoyed, and good luck for your exam for the upcoming test. And we want to see much more participation in the upcoming test that we're gonna be conducting. And the upcoming test would be a bit like more on the difficult side compared to this one. This was easier test. So yeah, do well, prepare well, and just enjoy the journey. Yeah, next would be the harder one. It will be really difficult. The difficulty level would be similar to the topic test and the subject test that we have currently in the test series. It will be similar to that. Okay, all right then. Bye.